engineer who is automation, he's an automation engineer, he's still an automation engineer, but he's more into oil and gas now. So he was one of the judges on the panel that day. He and Dr. Saeed of Green. Dr. Saeed of Green. So he was one of the panel. I mean, he was on the panel that day for the CIS conference. Engineer Dapo and the then IC chairman, he was with us that day. But for the contest itself, right? Yahoo was one of the judges, and we happened to win. I actually came first, and that was an limited edition of the SparkQuest. It was very insightful one because I had to make a lot of research about energy and smart grid regulators, right? And during my research, I struck on automation and also something like that. So I got to like Yahoo with automation engineer, and now I hook up. Yahoo, I was like, I'd like to meet you. Yahoo was working there at Crime Atlantic, Global Engineering Services, and Pages. And so since then, I got to know Yahoo, like, this is automation. I started being interested in automation, telling them what automation is about, little by little, I started having that growing interest. And then, I think last year, there was Nigeria Automation Fest. And that was, it was so, I am correct. I'm not even correct.
Don't graduate now.
Okay, you graduate now. So I am correct. We went together. And I remember I went to Europe and we got to Nigeria Automation Fest. And no, I already was on flyer. I got to see him. I got to connect him. I wrote anything around nice experience. Go and talk, and engineering talk was very inspiring. So that was how I got to connect with him. I got his contact, and quite a lot of people spoke that I connected with him. And yeah, as one of the most accessible people, one of the people that, as a student, if you have connection with him, it's a privilege, right? And it is an extreme privilege to have him among us here. I would like us to applaud. Let's find the meeting. Of course, we had over 100 people show interest for this training. However, all the impromptu, blah blah blah, was always plus tolerance from the school. This one was into the program. We're hoping to have number of people joining us, 100 of computers in our 10 minutes. During those things, I don't think that takes right. So back to the PLC automation control. The other instrumentation, I think it's international instrumentation. That was when I started studying about functions. Very interesting because I started seeing the maths behind the Sabo, started seeing the maths behind an automation sets. What was the maths behind it? When you have what's this thing called? Like the loci, this central thing that is completely linear thing, and this, and then you have automated, you have this transfer function here, you have this other one here. Let's see the maths behind what engineering of buildings, engineering of systems is about, right? And so, talking about a lot of things that engineering is very like maths. Engineering is very like maths. So, whenever you're learning, there's no way to waste. And so, when you have that maths in theory in class, you now have an opportunity to implement it hands-on. It's something that any student can forward to. And so, as we come together to bring this together, and it's going to be an awesome time. Engineer Dapo is one of the most seasoned engineers in automation in Nigeria, and I'll tell you that. Okay. So he's also here with skills and environment. Primarily, students can attest. We are doing what's the name? Yes, CAD.
PLC programming.
PLC. It's CAD generally, but it's specific skills, and we're doing analogy, right? So under that logic, we explore the language of PLC, that is the language that the PLC speaks, just like your Arduino, your Arduino Uno speaks the ID, the ESP speaks, and you get so the language of the PLC is that ladder logic, and all those transfer functions that will be resolved to that ladder logic is one thing that you can explore. And so right now we're starting with fast 11 and we like to start as soon as possible so that when people come around, they join us and we are already on the book. So I'll be reading the citation now, but I'm just helping display citation.
Okay.
All right. So our position here is an industrial automation expert, systems engineer, and technology entrepreneur with over 20 years of experience delivering control systems, digital transformation solutions.
Sorry.
All right. So with over 20 years of experience delivering control systems, digital transformation solutions, and technical training across the oil and gas, manufacturing, and energy sectors. He's a certified automation
Sure enough.
He's a certified automation professional (CAP) by the International Society of Automation (ISA), a senior member of ISA and a former president of the ISA Nigerian section. His career spans across roles in engineering, project delivery, and business leadership. Organizations such as next generation learning platform designed to practical labs, structured learning. His work.
So that was the first talk for the day.
privileged to lead the society for 2 terms. We have another person from TAG organization. And also, to make today a success, Dem Controls, the foremost systems integration companies in Nigeria, also supported this effort. And I will not be fair if I don't put out that acknowledgement. TAG Automation sent this engineer all the way from Lagos with the kits. My own kits I've not for almost 2 years, so I wasn't confident it would work, and I didn't have the time to have a look at it. So I just called them, and with 2 days notice, the young engineer had to come with the kits free of charge. They didn't charge me because they were doing a service for the community. So I want you to acknowledge them. If you get to make a post, a LinkedIn post about this event, don't just tag me, right? My own company's name is InsightWorks Limited. But 3 organizations made, in fact 4, InsightWorks, Dem Controls, and TAG Automation, right? Made, and then ISA. Of course, I can't forget ISA.
Yeah, good to you, man. Well done.
Organization, and they made this happen. So thank you very much. I'll just allow them to make a brief introduction, and TAG Automation will tell us what they do. And I mean, those are the places you can reach out to when you want to do your IT. If they have suites, they'll actually offer you space. So that's the introduction and the mission.
My name is everyone. Student Nigeria. So I think last night or some weeks back, we had a program in India to commemorate the ISA Day, which is the American Center of Information Day. So on 28th of last month. Yeah, so we had an awareness program for them to children and know what the nature is and how about when you're affected by the bad sector of because you guys are lucky and these guys are in control. It's on schools, they don't know what is control. You know what is KLC, they don't know what is education. So after school, maybe you have an uncle, you have somebody when you're class and you're pattern, put you, it's okay. I've heard of organization before, you know that these are these areas. But we are trying to bridge the gap of industry and school. So we are looking for a way to make sure we have automation in schools. We already started, the third one we are trying to be the student member of the ISC. So when I started the flyer, I spoke to my boss. So I'd love to create so I can engage guys and see a way forward. We can have a student branch of them. Hopefully, after the program, I want to necessarily we can also have the same awareness like we now. Also, so that you can see about it. So those are one of the things we have planned for students from the grassroots from ISC. Thank you.
And automation engineers have applications. Also, you can do which kind of thing. So, automation, we offer industrial application services across manufacturing industries, oil and gas industries, FMC industries, and also we offer trainings as well, especially automation internship programs to last for 6 months. So, we have people working, and we have more practical knowledge. So, here you have it that one just need a few hours to spend. We study the background knowledge you need to get as well. So, just thank you very much.
Okay, thank you guys. Dem controls is not here. Maybe if we have it, I can probably call the MD, who is also a former IFC president, to just say a word over the internet. All right, so we can start. So the topic today is from transfer functions to ladder logic. And so my goal today is not to convince you to be an automation engineer, right? What exactly does that mean? Who is an automation engineer? We have AI automation, we have so, okay, right. So, my goal is not to convince you to become an automation engineer. I am a control systems engineer. I am a very proud engineer, right? I mean, it's what I love to do right from when I was very young. And I was very lucky to get into an EE program, the only program I wanted, right? I was very lucky to get that admission and I got it there. And again, I was very lucky to attend a secondary school where I did electronics as a subject. So right from SS1 to SS3, I was already building circuits, right? I mean, I didn't see design. I could design. They told us we could design simple amplifiers, multivibrators, and so on and so forth. But if you give me any schematic, I will solder it, I will reproduce it, right? And that was the foundation I had going into the EE program. And then all through university, there was so much divergence from what I learned in secondary school to what I learned in university. And I actually thought at the time that probably my secondary school training was more valuable than the university training. But in final analysis, it's not so. Because on the surface, yeah, I could do the physical things, but the university education brought the system thinking, right? It helps me. So it's one thing, I mean, a number of you have used the Arduino, you know. You can do some connections and whatever, but if they ask you, design an Arduino board without going to the internet to download anything, a lot of people will have problems with that. And that is what the principles you are learning in the university is teaching you. System thinking, right? How do you process, how do you acquire an input, process it, and get the desired output? I want to build a factory, and then I come to you engineers and say, well, I'm just a business person. I want to build this factory. This factory must produce powdered egg. Powdered egg. You say, okay, I've never heard of powdered egg. And then you say, okay, describe the process to me. I said, well, I want to take the egg from the farm, break it, right? It's in liquid form. But, so that is going to be the input. By the time you are done, I mean, performing your engineering margin, I want to have powder, something like powdered milk. And then you now sit, put on your thinking cap, begin to look at processes. Engineering is essentially the application of science, right? You begin to look at processes. How can I convert liquid, or even we can regard the egg as a slurry. How can I convert a slurry to powder? The first thing is I need to extract all the water molecules in that slurry. Once H2O is absent, then it becomes powder, and then I can blow it, right? And then you go back, how do I do this thing? And then you look at, okay, maybe vaporization. So if I pass this egg through a very tiny hole, right? And then I expose it to air at the right temperature, you know, such that a X quantity of the slurry is passing through a section of the chamber, and it is being exposed to X amount of air at X temperature, right? And then you discover that from this top, boom, by the time it's coming down, it is flakes that you are getting, right? And then your next task is now, how do I maintain that temperature? How do I ensure that volume, the right volume, comes out, right? So that now becomes your task as the engineer. So you can begin to see my reason for saying that I'm not here to tell you or to convince you to be an automation engineer. My goal today is to help you to connect your engineering training, right? Engineering training to the practicalities outside school. The practicalities that you can, you know, train yourself to hold, and you'll be able to command the kind of income you desire. Maybe by the end of today, you will sit down, reevaluate your career and your journey, identify the things you need to learn, identify the skills you need to acquire in order to ascertain the future you want. And that's essentially what transfer function is all about. Transfer function is a ratio of the output to the input, right? What's the ratio of 10 to 5? 2. That's what transfer function is all about when you distill it to the basis. So you can begin to see that one of the strong advantages you have as an engineering student is that, I mean, whether you have F in mathematics or not, I know that you have an aptitude for mathematics. Whether you have an F could be that maybe you were ill during exams or you didn't care much about the course or whatever. But for you to get into the engineering program and for you to get into that in UI, right, you have an aptitude for mathematics. As in, for you to get into this program in UI, you have an aptitude for mathematics. I can say that 100%. So meaning that you have the starting points. You have the starting points. You have the raw material upon which you can build a lot of things. And we'll see it in the presentation. Don't mind me. I love the sound of my voice, so I stray from my agenda a lot. So we'll rush through this. I have about 35 slides here. We have about 15 to 20 minutes demonstration. And then, so Skill Catalyst is a platform that, I mean, over the years, after conducting technical training, and I felt that this setup here, easily, if you want to buy this setup, you probably will be looking, everything here, you'll be looking at about maybe between $10,000 and $15,000. So it's not easily accessible. You step out of school, I would say, I want to employ an automation engineer, and then you must have, you must be able to do ladder logic programming, you must be able to do this and that and that and that. And then the question is, where do I learn ladder logic programming as a fresh engineer? Right? Where? Approach people that will conduct this training, and you realize that, well, it's a chicken and egg thing. You can save up in your youth service, go and do training. Probably this training will take half of your youth service income to do probably 1 month's training on this. That's a lot for a young person. So we thought that, okay, maybe simulation will bridge that gap. If it's something that's really interesting to you, you will take that first step, understand the fundamentals, at least understand the terms, understand how everything connects. Then, when you go to take a training, right, you go to tag automation or DEM controls to take a proper hands-on training, you will be able to maximize that class because there will be so much questions for you to answer. You won't go into that class and be learning scan cycle. You won't go into that class and be learning what is a PLC, what is SCADA. You would have done that on your own in the fundamentals, and then you'll be able to maximize that investment. So that is what Batted Skill Catalyst. You can actually write PLC codes. There are, I'll do a short demonstration of it. There are a number of scenarios, industry scenarios, right, that you can go through. And for an automation interview also, it will really help to ace such interviews. Okay, so about today, what this is and what it isn't. It's not another lecture, but it is designed for everyone, 100 level through 500, right? 3 hours in the room. By 1 p.m., you should be able to understand a working closed loop motor controller and save to your own SK account if you have one. 2 questions. You are studying engineering. At some point, you will leave this campus. What happens the day the real world asks you to actually build something that works? Your peers are learning Python on YouTube and they are getting offers. Some of you are already saying school is scam. We'll try to answer that question. Are they right? Should, huh? Yeah. Yeah, not sure. It's relative.
Everybody sees value. Some people understand. Like what they were told, their expectations is not what they get when they win.
Well, I mean, yeah, I mean, so again, everybody have their opinion. You have yours too, and you just share. And see, it's actually debatable. Maybe because I'm an engineer, I am very biased towards this profession. And I feel that there is absolutely nothing, no field that you cannot get into. In fact, I feel that God himself is an engineer. I mean, look at nature. Look at nature. If you pay attention to nature, if you look into space. I mean, one of my hobbies is I love neuroscience because I love to understand how the brain works. I am an amateur neuroscientist, right? And then I am an amateur astrophysicist because I read a lot about space and, you know. Engineers built the Voyager. Voyager was launched 1 month before I was born, 1975 March. Voyager is still flying today, remotely in space. After 51 years, Voyager just got to the edge of our solar system, where we call interstellar space. Let us sink in. 51 solid years. The spacecraft traveled continuously at almost the speed of light. And it just got to our solar system. There are billions of solar systems in the universe, right? And it just got to interstellar space. Human mind built such a system. Now, think about the Almighty. Whether you believe in God or not, it doesn't matter here. Whether you call it nature, whether you call it God, whether you call it, what else do they call it? You know, whatever it is. But you begin to look at the vastness, right? I read something recently, the chaos theory. And look at the grasses outside. If wind blows now, all these leaves, they will move in what we call an haphazard motion, Brownian motion from physics. We don't understand it. Scientists already studied what they call the chaos theory, and they can understand a boundary of the movement of that chaos. But I believe that something that brought this forth, there is some kind of order that we are yet to discover, just like we are yet to discover the frontiers of space. All right, but let's not get into that. So, school is calm, are they right? We'll find out. What is a transfer function, really? Like I said, it's a ratio, right? And look at the analogy here. So we have the mathematics, right? We have the analogy applying to me, and then the analogy applying to the industry via the PLC. Your input signal is equivalent to your years of study, your efforts and sacrifice. That is your input signal, right? And that is the set points we are applying to PLC. Your output signal is your career, impact, income. So, JAMB fed you into the university system, which is, let's say, a black box. A lot of functions that you have to go through, and you have to combine everything, right, such that you get an output. That output is directly proportional to your career, to the impact you're going to make, and to what your income will be. Right? Now, the PID algorithm that you learn in your control systems, proportional, integral, and derivative, right? Proportional is a smart work. You see the graph later on. It responds to the error in front of you. It is fast, direct, and gets moving, right? Your proportional action, the bigger the error, the stronger the push. I mean, look at your GP. If you have a target GP, right, you see that maybe in the particular semester they did it. And if you choose to maintain that targeted GP, which is your set point, the efforts you are going to put in the next semester is much more stronger, right? Now, you put in that effort, you now add your KR, your integral term, which translates to character integrity. That is the accumulated weight of who you are. It corrects the gap efforts, the gap which efforts alone leaves behind. This gap does the correction. And in the control system, the integral term eliminates steady state error over time, right? And then your KD, your derivative term, which translates to foresight, it looks at the error, the future error, and it does the correction. Now, it anticipates where things are heading, dampens overshoots, and stops burnouts. And then it slows action as the target approach, right? So if you have all of this, IKP, I proportional term, no integral term, no KD. That is, you have just smart work, no character integrity, no foresight. The result is burnout, wrong direction, no savings, all positive, no wisdom. And that is what we need to begin to play, right? Instability, oscillation, persistent error, and system faults, right? But in well-tuned, if you combine efforts with integrity and character and foresight, it reaches the target very easily. It settles, delivers. It is right, not just fast, right? Fast rise, low overshooter. And how does this apply to you? So that's why I said that we need to begin to calibrate where we're going. Do you really have an input signal? Do you have a set point? Do you have a target? I mean, are you even giving it a thought? What's going to happen after you leave this environment? Are you just hoping that, okay, I will get a remote job? Or at first, I'm going to do what do they call it now? Digital marketing course, 3 months, and then social media marketing and whatever. You expect someone that does it right. It is a mediocre skill compared So what you already have in you, and you are not translating it. That mathematical and scientific foundation, it's in you have skill. Right? I am not a trained software developer, but my engineering training taught me logic. If your philosophy of logic, I know you guys have done that philosophy of logic, right? Yeah. Modus ponens. If A equals to B, B equals to C, then I know that A equals to C. I can derive, I can go from input to output through logical steps. And then now have this 5 years training, right? And then you are now looking at making money from the 3 months training. That is low hanging fruits, right? Do you know that the study has shown that engineers actually do better in managing companies? And in fact, you can Google it. In fact, 33% of Fortune 500 companies. Fortune 500 companies are the best 500 most valuable companies globally. 33% are led by engineers or people with engineering training. And it's simple. We understand inputs, processing, and outputs. We have that understanding. See, by default, that is how we are structured. And that's essentially what business is. Bring in the raw materials, process it, deliver it to the customer. All right. We move. So what we are doing today, we look at a theory, we look at the gap, the translation, the opportunity, and the bridge. So the question, did AI produce these slides? I want you to have that question in your mind. We'll come back to it. All right. Did AI produce these slides? You know, you can type a lot of things, pass it through AI, and yeah. Think about it. Think about it contextually also, right? So just put on your engineering cap and, you know, so we'll come back to that. So 100 to 200 level, you haven't done cover transfer functions yet, but you saw the analogy that it applies to everyone, right? Mathematics is the language of the universe. Yesterday, I was watching a video on Fibonacci sequence, and it's just amazing. You look everywhere in nature, and you see this theory all over. For 300 to 400 level, you are in the middle of building the foundation. And today shows you what it connects to. The translation will make your coursework land differently from here. And the 500 level, today is the missing link between what you have studied and what you'll be asked to do. The hardware is in the room, the program is in your hands. You are the engineer. You use the hardware, you command the hardware as you desire. And you need to begin to think. I mean, so I see a lot of people put on their CV, embedded system engineer, this and that. Many of them are makers. Engineering is different from making. Making focus on function. Oh, it works. It works. When I built my first multivibrator, right? I mean, electronics in secondary school, and I've been trying it. The concept of time constant was, I mean, I wasn't familiar with it, with that calculation, the RC constant, right? And then I didn't know that it was already working. I just couldn't see it, you know. So I connected an LED to this output, a bistable multivibrator, LED A, and both LED came on at the same time. I didn't know that my time constant was too fast, that the LEDs were actually switching, but my eyes couldn't recognize. While poking around days, I just changed one of the resistors, and then pam, 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 pam. The thing started blinking. Amazing. I just ran out and said, it worked, it worked, it worked. And then my dad came and said, okay, it's worked. I said, it's blinking. And the man asked me, so what is the use of this? I had no idea. I mean, I just said it's for decoration, that you can set it on a wooden block and then it will be shining and coming up and up. I never knew, I mean, multi-vibrators, of course, you know what it is for. You know, so that is what makers do, right? It works. Engineering sits at the intersection of functionality, sustainability, and the economics. Whatever you engineer must make sense economically. It must be sustainable. Sustainable that it will last and it is safe, right, for use, right? And then, of course, it must function. So when you have those three cycles intersecting, the intersection of those three terms, that is engineering, right? So what you are building, your engineering toolkits, you have your mathematical rigor, your differential equations, your Laplace, Z transforms, and linear algebra. And I'm going to say that you guys need to take this very seriously, right? Linear algebra is the math of machine learning, right? You need to begin to see it beyond, I mean, those of you that did further maths in secondary school, I mean, it's essentially polynomial, right? You understand quadratic equations, and then you understand polynomials where you have x raised to power n, where n is greater than 2. Where x raised to power 2 is for quadratic equations, but polynomials, we have x raised to power 32 or whatever, right? And then the systems thinking, modeling, feedback, stability, and optimization, right? You take the system, right? You take an existing system and you optimize it. You extract more value from it. As an engineer, you get into an oil field and they say that, okay, you know that we still have oil wells that has been producing for the past 50 years. They've been producing, but they are declining with age. And then they said, look, we feel that we still have more oil in this reservoir. Can you, as an engineer, help us to recover more oil, maybe faster or more sustainably, right? So you do your study and then you create an optimization plan to get more oil from that reservoir. Your learning control theory, PID, servo mechanisms, closed loop designs, you have hardware intuition, your signals, your transducers, your actuators, and your real world constraints. You know, these are the things that all the courses you are running are imbibing in you. My passion is that we need to see these things in light of their applications. Let's not just see it as what you need to do to just pass exams. If you are going to pass the exams, why don't you add that little effort more to know it, to understand it more, and to be able to apply it, all right? When you use your Arduino, your Raspberry Pi, and so on and so forth, you deal with signals, you deal with transducers, you deal with actuators, right? And then programming logic. Algorithms. What are algorithms? They are essentially math formula, right? Algorithms, state machines, and conditionals. So we have the same language, the same system, but two completely different languages. You look at this, and on the left side, in your lecture notes, that's what you will see. GS equals to K divided by that funny shape S plus 1. And that's constitutes a closed loop feedback system. How many of you have done anything with Arduino there? Okay, you tell me, what have you done with Arduino? What project? Just tell me one project. Just describe it. An automated water pump. What was the input? No, something that detected, I mean,
Okay. So my effort for time. Sense of this, what that sense of there is a lot of sense.
yeah,
Right, so it makes the measure things else.
that's input. So you have a level measurement. Okay.
So when it detects that there was spoken certain constraints or certain it's going to send the message to the and then the relay sends the tons of the kind of
So you have an input, you have something that processes inside, and then you have an output. And would you say that this system models what you have just described? Can you see any connection there? Tell me.
yes. There was a feedback.
Yeah.
So it sort of it's from the value of the rate from the value that whenever the model was, whenever the concerning time, so it's used that as an option. So it is that as its limits.
Okay.
That's
Okay. Now, in your project, what would you say is this value? This value is called set points. Do you implement any set points in your project?
so there was sequence
Right? And then what is the PV? Don't worry, I mean, you might not, it's a technical term. The PV is the actual level of the water. I mean, we call it the process period. Right? So you have the set point, that is where you desire the water to be. And then you have the PV, the actual level of the water. And then in your logic, you implemented this error summer, E of T, which is equal to SP minus PV, right? And then you get your controller gain. This is what determines, so based on this error, this does the correction. It just generates the signal and it determines how long the pump will run to get to this desired level. Makes sense? So, thank you, sit down. So you see that you have intuitively implemented a control system. What level are you? 4. You've implemented a control system, you did not even bother to model this. If I drop this in front of you and give you a profile based on this, you will get intimidated. No. I mean, let's assume that you did it as before you did a control system for. Do you believe that with 200 or even 100 level students can implement the same projects? No, not the solution, but can implement a sense that water pump system. Yeah. So you see that just seeing that project somewhere and implementing it, this is what you have done. Many people have done this kind of projects. They go online, they take the project, they copy it, and they implement it, right? And that's why you hear, I'm an embedded systems engineer or whatever. And that's fine, right? But you can see the advantage you have. If you now decide to say that, I want to create a more reliable system, right? Because most likely, your project will probably waste energy. Reason being that your SP might just be a single value and not a range. Which means that once, let's say your SP is 50, once you attain 50.1, once you attain 49.5, your motor will start, right? And then you'll be starting that motor up, boom, boom, boom. What is the indication of starting the motor off? Your motor is the same thing as a pump, right? Every time you start a motor, there is an inrush current. So you have consumed energy. So as the engineer, you can begin to see the thinking. When I approach that problem, I look at the economics. Because operating the motor, and that's why I choose that slide. Just think of one industry, one single industry. Any facility that produces anything in mass. Just think of one that doesn't have an electric motor. None. So operating a motor is very important, but then it's an energy guzzler. It's a source of PMC problems. If I tell you the problems I've experienced with electromagnetic interference due to motors, compressors, we don't have the time. But you can see all of this. You have this understanding. I can actually pick someone that did Yoruba, and this is without bias to other courses, right? I'm just emphasizing your training, right? I can practically pick someone that did Yoruba and teach him how to write this. XIC, examinate flows, examinate open. These are contacts. OTE, output energize. PID. I can literally teach that person within 1 week. And that person will be able to write this program. But that does not mean that he or she will understand what is behind it. This is what will make you to optimize the process. Imagine, look at Nestle. I used to work for Rockwell Automation and Nippon Schneider. One of my job was I visit a lot of factories, right? Because I advise on architecture, I advise on optimization, right? Look at Nestle. Nestle produces. I mean, I don't think I even know all the products produced by Nestle. Migros, Maggi, all those food items and everything. So they have a lot of processes, and each of those processes run motors. Right? If you can save Nestle, if you can write programs, if you can create this model that save Nestle, let's say, okay, no, let me not use Nestle. Let me use this example. Coca-Cola produce, let's say Coca-Cola produce 100,000 bottles every day. You think that's possible? Yeah, I mean, of course. More than, I believe that more than 1 million people take a bottle of Coke every day in this country. So 100,000 bottles is nothing, right? But let's say they produce 100,000 bottles every day. One bottle is 35 cl, right? It's a control system modeled by this. The desired bottle, 35 cl, is the set point. The actual bottle is PV. The actual control state is when we have SP minus PV. Now, assuming that SP minus PV, you did not do this optimization very well, and you introduce 1 cl error. So you have -1, meaning that instead of injecting 35 cl in that bottle, you injected 36 cl, right? Just 1 cl. Now multiply 1 cl by 100,000. That is 100,000 cl wasted per day. Because what Coca-Cola promised you is 35 cl for maybe 200 naira. Well, now they are giving you 36 cl because the control system engineer was incompetent. Now, divide 100,000 cl by 35 cl. Can someone quickly do that? 2,857 bottles wasted every day. Multiply that by 30. How much is a bottle of Coke? Multiply that by 500. So approximately 42 million. An incompetent engineer that does not understand this at the system level will cost Coca-Cola every freaking day. Just by introducing 1 CL. How big is 1 CL? So you can begin to see, just now scale that. Let's say Coca-Cola produces 1 million bottles a day. If I was the FD, I would fire that guy. When he's fired, I'll fire him again. So the guy that just went from outside and picked this up without the necessary background will not be able to think at that level. So if Coca-Cola calls me and says that, look, we are not meeting our revenue targets. So you'll be surprised that if I want to market to Coca-Cola, I'll go to the financial guy and say that let's audit your process. Are you giving more to customers than what you have promised? We all know, look at advice here. We are all used to it. I grew up with that advice here. So I don't expect more. So if you give me 1 extra, it is a thankless job. Coca-Cola will be losing, the shareholder will be losing, and I'm taking in extra sugar. So it's absolutely useless. Do you understand? So the control system must deliver this E of T, SP minus PV must be 0 for every bottle. And that's a very massive task. And it is only people like you that are capable of getting that done. So you have, I mean, the GSK and whatever. So you can begin to see that this stuff you are seeing here, right, is directly transferable to your practice. So the translation problem, you have the academic, expresses it in mathematics. You have your Allen Bradley PLC, I mean your PLC, you know, there is a PID block, plus all your ladder rungs, and that's your industrial programming. And then you have your Python. In your Python library, you have your PID compute. Guess what? In Python, in programming, all these PID, complex, whatever, all these things, you implement it under 4 lines of 8. Just 4 lines. In the loop, that's all. This formula again, right? This formula. Even you say that you don't want to work in the industry, you don't want to do manufacturing, you don't want to do automation or whatever. You want to do tech. Huh? So you want to do tech. You want to know how to do Python. Ish. Okay. Don't forget your roots. Are you Yoruba? Ah, okay. I will have said more anything one shape. Know the child of, know the daughter of whom you are. Know the family you came from. You are from the engineering family. So those three. So if you want to do tech, which is valid, right? When you get into tech, you should actually be distinguished. Drone. How many of you have used the drone here? If you have flown a drone, okay. How do you fly a drone? How do you direct a drone sitting there and then it goes up, and then probably you're looking for something on that tree? and you direct it to the right place. How do you do that? It is through this algorithm, the PID algorithm, the control. Because you give it a set point. Every time you direct it to whatever, you are giving it a set point. And then the processor processes it. And then the output, and then you are continuously checking your SP minus P. You use the PID algorithm to position the drone wherever you want it to be. If you want to take a picture, you use the PID algorithm to ensure that you have a very perfect view. So now imagine you that has been trained in mathematics, having to write a pen web for a drone. Your approach should be much more different from the approach of others that are not trained on this. So you can see that this training you have is not restricting you to the plants. Right? I used to, in a past life, I used to fly in helicopters a lot. Probably I do as much as 5, 6, 7, or even 10 flights in a week. You know, jumping from locations to locations. And then you sit up there in an helicopter and you see water. And then the helicopter is shaking like this. And whatever. Well, it never crashed. It never crashed. You know, many times your house will be found boom, boom, but then keep a straight face. You know, it'll be breathe. You know. But when you look at it in high winds, in no wind, in still winds, the helicopter will still be able to go to where it's going. Sometimes it's going this way, but it will just go this way. And then do a call. I read on that place. All of those are being able and enabled by this. And let me tell you, this is just what we call the classical control theory, the PID-ish. That is the classical control theory. All the advanced control theory, all of them were built on this. So now, those of you getting into machine learning, AI, and whatever, back to the drone example I gave, right? Let's say that we need to count all the leaves, or we're in the forest. So, for example, IITA, maybe they say that, okay, once IITA sits on about 1,000 hectares of land, right? Then they have the forest. I've thought the forest very interesting, right? They have the forest that have been left untouched for almost 60 years. So the foliage in that forest is very rich, as in you on the dead plants. It's as if you are seeing a very diverse environment. You see a lot of birds and whatever. Yeah. So let's assume that they say that, okay, we want to know the number of trees here. We want to be sure that people are not coming to cut these trees down. Right? You will see find the Iroko tree in that forest. In other places, they have cut them off. You know, and the Iroko takes a very long time to, you know, and they want to come, and they come to you as the engineer. They say, okay, how can you help us? Who can suggest a method to me? How you will approach that problem? To count the number of trees in IITA forest. How would you approach it? Yes. Can you give him the mic?
Is what I was just as I'm ready is using the drone with the camera, and then the camera is paired with object detection, and then using object detection and mapping out the entire area of the forest, arranging your plants with, you are able to count and make sure you cover, sweep over every area of the forest and count each one of them based on the object detection that the camera brings.
So how do you ensure that you prevent against anything when you are marking?
Yeah, actually,
What method maybe okay, what do you use to do your mapping? No, this will be your mapping for you. This will be your positioning. Because something needs to do your mapping, and then this will direct your drone that okay, this is where the market is. Don't go beyond this area.
possibility to place.
Exactly, you take the coordinates. So your drone takes in the inputs, the coordinates as inputs, right? And then says that I'm defining this coordinate as zone 1. I define this other coordinate as zone 2, right? And then once you do that deployment, object, what do you call it now? Object detection. How do you achieve the object detection? AI models. Exactly. So you use AI models. Will that AI model work without you being able to position your drone? It won't. It's useless. It's useless. So you begin to see the importance of this algorithm. Right. So in the tech software and tech market, you have this. At some point, you should be able to take this algorithm, right? Madam Tech, you should be able to take this algorithm and then properly fit it, customize it in specific applications. That is where you guys should shine when or if you choose to go into tech. I mean, if everybody says that, oh, let me go to Amino Library and download and just do it and whatever, you shouldn't be doing that. Yes, you download, but let there be your intellectual input in that. Even if it is a perfect library, understand how that perfect library works. Because that is where you can now begin to add improvements. So your skills stack, what it's actually worth, right? I mean, this is based on a Coursera, what's it called now? Research online, right? You have your automation and PLC engineer, which immediately give you usable skills into the oil and gas, manufacturing, cement, mining and metals, pharmaceuticals, and all this production economics, sector. You have ML and AI engineer. You already have the maths. Python is the last mile. Huh? Yeah, it's tech. No, I agree, right? But the point I'm making is that the mathematics, all these transfer function, the Laplace, and all of those things, you have all of that, right? Python is the last mile. Robotics engineer, controls, code, hardware. These are things that CS graduates, computer science graduates cannot just jump into. Don't mind the guy. He's looking down on computer science students. How many of you have heard of rotational mathematics? Sorry, rotational matrices. Yeah. Yeah, I mean, if you're doing robotics, you need to understand that 6 DOF, you know, your degree of freedom. You know, you stack 1, 2, 3, and then you want to position this to be A. You first need to move this will move this, and then this will move this. So you use root math, you know, to model that in 3D space. Those are the skills you have innately in you. That's why I said that even if you have F in mathematics, even if you are, I mean, I hope you are not, even if you are third class, what's the degree level now, right? For you to even enter into this university, right, it is the chances of entering this university, engineering in this university with less than 200 in JAM is very low. I don't know whether it exists. It's 0, right? Thank you. So if you can score, if you can perform maths, physics, chemistry, and English in JAM, and you do over 200, there is an aptitude already. And if you succeed from 100 level to 400 level in this university, I mean, it speaks a lot already. All right. So that is my emphasis. Now, for IoT and embedded engineer, talk about your firmware, your real-time operating systems, your edge computing, and then remote friendly, right? And all those and the SCADA and industrial software, Ignition, WinCC, FactoryTalk, and then energy tech, battery systems, grid control, renewables. You know, this is a very fast-growing field. The maker will build a drone, right? And then the drone will fly for 10 minutes, and then the battery will be gone. But the engineer will build the same drone using the same material and the same battery, and that drone will fly for probably 30 minutes. That's where you begin to see the difference, because the engineer will take a proper audit of power consumption in the circuitry. Every resistor that will dissipate excessive heat, that will require one fan to work harder to dissipate, which is essentially a waste, the engineer will optimize around it. I hope I am making sense.
Yes, sir.
I hope with this little speech of mine, I've been able to confuse you and not convince you. I mean, is that not how they say it? All right. So the honest comparison, and this is between the tech people and the engineering students. Python, no systems foundation. You are competing with millions for the same junior roles. You cannot reason about hardware or control loops. But for the engineering students, you have the mathematical rigor as a foundation. You have the systems thinking baked in. All the proofs that you have to do mathematically. It's not just, it's a conditioning of your brain to think in a systematic way that you derive. It's not just that they are punishing you to say, what will I use all of this thing? Math is not scamming.
No.
It's a conditioning of your brain. You get somewhere and people start arguing and you look at it, and then when you talk, everybody has been arguing this way. The engineering student now went this way. And everybody, oh, okay. I never saw it that way. It's because they will give you, I mean, it is maths. Maths is numbers, right? And then they will give you letters. To go and find X. Why will I find X? But you still need to logically find a way to convert X to some numbers. That is systematic thinking. Right. So these things are baked in. And that is what helps your ability to solve problems. Right? When you look at problems and you realize that you can possibly you get a problem, and the first thing is, well, they ask you, is it possible? Well, I mean, nothing. If you ask me, is it possible? My first answer is, well, nothing is impossible, but are you willing to pay the cost? No. If you give me, if the cost is unlimited, I will solve the problem. All right. NASA just sent, what was the last flyby? Artemis 2 around. Do you know the estimated cost for that mission? It's in billions of dollars. If the US government was not willing to pay billions of dollars, that wouldn't happen. Someone prioritized that program. And then we had a 10 days flyby, right? And then we blew billions of dollars. Years of preparation. Artemis 2 program started which year? I think it started 2 years before Curiosity was sent to Mars. Yeah, I think Artemis 2 program started. So they already had full-time staff, full-time people working on Artemis 2. When they started, the spacecraft wasn't built. It was an idea. So if you are willing to pay the cost, I'll solve the problem for you. So I mean, this brings us to the platform. It helps to bridge that gap, right, between the theory and the practicals. All the physics behind the processes, right, they've been modeled and converted into codes, right? And you can actually run it. I'll show you a model, a plant that we modeled, right, on the platform. You have, so it is built for engineers. It's filled with a lot of simulation. So you've got simulation labs, and then there are learning parts, you know. So if you do not have an account, you need to get one now. You will probably will need it in about 20 minutes, right? We'll do some demo on it. So you can open that URL directly in your, if you are not registered, it will ask you to register, but you can open it directly in your browser, that URL. I will give you a few minutes to copy it, and then we'll continue. Wow. Okay, so I'll need to, you know, so that we don't keep people waiting for too long. I know you guys are, exams are approaching, or what's the, next week, next 2 weeks, amazing. Next week, okay, so you guys need to, you know, so, yeah, you say? Yeah, you need to study the physics of the, exactly. All right, so, okay, let's, we're supposed to have a break. Should we continue? Okay, no, I think it's, that. Okay, the picture is not, so that's the Allen Bradley PLC. The PLC, Allen Bradley is one of the top OEMs that manufactures programmable logic controllers. And this, sorry, say that again. OEM is original equipment manufacturer. So we have Allen Bradley, we have Siemens, we have Yokogawa, we have Schneider, we have Omron, we have Beckhoff, we have a lot of them. And this essentially is a computer, right? We call it an industrial computer. It has the inputs, it has the outputs, it has the CPU, central, what's a CPU? Central processing units, right? It's got its own power supply. Is that a card? That's yeah, thank you. So this is an input card. Okay, you remove the, yeah, so that's the, can we pass it around? Okay, just pass it around, right? Okay, that's the CPU, okay. So this is the CPU. You can see that it has a battery, right? So careful, don't touch the circuitry, right? So you can just pass it around. So, and it's got terminal blocks where you connect your sensors to. In Arduino, what would be the equivalent of the terminal blocks in Arduino? Yeah, your GPIOs. Yeah, your GPIOs. Those are, because you connect your sensor to the GPIO. You configure your GPIO as either an input or output, right? So, but for the PLCs, we have dedicated cards for inputs. We have dedicated cards for outputs. We have dedicated cards that will take analog signals, right? And then the ones that will take digital signals. And then it has its okay, yeah, so there is communication card also that excuse me. Yeah, so it's got the communication card. Yeah, you can give it to him and pass around. So it's got a communication card, and you can, so that you can connect, just like you can network your computers, you can also network the PLCs. Yeah, tell me.
So can we say that the Arduino is like for smaller projectors for development, this is the main deal in the industry, like solution?
So there is something we call determinism. Determinism simply means that if I say take 5 steps, not more than 5 steps, I can go to sleep that you will take that 5 steps and not 5.001 steps. If I give you a bowl of rice and I say pick 18 grains of rice, I want to go to sleep and say that you can pick 18 grains of rice. Now, let me explain that. This PC, if you overload it with software or whatever, at some point it will crash. You will have the blue screen, right? The blue screen of death, yeah, it will just boom, and then your chest will cut, bam. Hey, I hope I've not lost all my data. We cannot afford that on a PLC. So a PLC is deterministic. When it fails, we understand how it is going to fail. As in, if it is going to fail in the future, we know how it is going to fail. So it is deterministic. Arduino is not deterministic. Yeah?
So in the end, it's just one program that runs continuously. Like an Arduino now, you can program different things.
No, how do you program different things on Arduino?
Like today I can decide I want to do it, like tomorrow I can decide I want
So you write another program for Arduino? No. Today,
yes.
dimmable lights
Yes.
running on the Arduino.
Yes, with my breadboard.
Yeah. Then tomorrow, you write another program.
For like the temperature sensor.
Yeah, the same thing.
Okay. Thank you. That's much.
The same thing. So today, I can choose to use this on a conveyor line. Tomorrow, I can choose to use it to monitor that Coca-Cola level. Next tomorrow, I can choose to use it to count the number of people entering this faculty. So you can always reprogram it. So the only difference is determinism. That is the only difference between this and a computer. For your computer, you want fast processor, you want very high RAM, and all of those things. I really don't care about it. Determinism is my #1 priority. Because imagine, for me to produce 1,000 bottles, 100,000 bottles of Coke, I'll first get a recipe, mix the sugar with water and everything, right? In one giant tank. That giant tank is what I'm going to portion into bottles. So it's going to come out through a valve, right? Now I'm using this PLC to control that valve, to open and close, right? Just imagine if this PLC fails. If this PLC, when it's supposed to close, and it just opens permanently, and then you have a river of Coke. You just have a river of Coke. That's even good. In the oil industry, you can imagine what will happen if hazardous product escapes, or this PLC is meant to keep pressure low in the vessel, and then pressure begins to build up, and this PLC will not detect it. So you can begin to see why I can easily pay $15,000 for this box, and maybe I'll pay $500 for this guy. They are both computers, but that is an industrial computers. You said?
Yeah,
It is deterministic. So I can go to sleep that it is going to behave as I want. As I am working now, this thing can shut down on me. Right? But we can accept that because it's not critical. But in the industry, you will lose money, you can kill people or injure people, you can destroy the environment. So that's the strength of the PLC, and that is why it is different from Arduino or Raspberry Pi. So the closed loop theory, I'll just gloss through this. We've discussed it. I've sent these slides to Mr. President, so you can get it from, because of the time. I want us to just have some time with that stuff, right? So you can see the same equation in 3 languages. So academic, right? This is U of t equals to KP, proportional term plus integral term, and plus the derivative time. In PID instruction on the PLC, this is how it is. Your control block, you have your SP and PV, KP, TI, and TD configuration. And then look at it in Python. 1, 2, 3, 4. 4 lines implemented in Python. But the tech people, you can write this. You cannot tune it. You can write this Python program, but you cannot tune it. What do I mean by tuning? Let's hold it. I'll show you in subsequent slides. I'm trying to run through this here. So, just merely look at this graph. Which one do you prepare? Which one do you think is which color? Green. The green. You started your process from 0 to 3, right?
Hello, please. Please, can I ask a quick question?
Is someone online?
Yes, I want to ask a quick question.
Okay.
Yeah,
All right.
So, how can you relate the determinism of the PLC? Let's say, can you explain in terms of maybe time constant or settling time of a particular product? Let's say you want the level not to probably exceed a particular set point, or you want the flow to be consistent at a particular flow level. So how can you explain that determinism that you talked about that the PLC has in relation to a personal computer or an Arduino?
Okay. Yeah. So thanks. You didn't introduce yourself. I actually forgot that there were people online listening to us. Thanks for asking that question. And so what you just asked has to do with what we call process dynamics, right? There is the actual nature of a process. If you boil water now, if you put water on fire now, whether you put 1,000, whether you apply 1,000 degrees of heat, it is not going to boil immediately. It will take a time t because of the physics of that process, right? There has to be heat transfer. Heat needs to move, and the nature of its movement is sluggish, is slow, right? So that is where time constant comes in, right? So we cannot go into process dynamics fully, but it is modeled on the Scale Catalyst platform, right? But when you are configuring this, let me go back. Yeah. So when you are configuring this, because I just mentioned that you can write that program as a tech person, but you cannot tune it. To tune it, you need to understand the process dynamics. How do you know the right value for K, the proportional term? How do you know the right value for the integral term? How do you know the right value for the derivative term? That is what we call tuning. The values you use for boiling water will be different from the values you use for frying plantain. It will be different from the values you use for filling a Coke bottle. So that is the tuning problem, right? So you will have factored that in your program. Determinism only says that this PLC, while running my algorithm, even if life happens and it shuts down, you cut power from it or whatever, it is going to fail in a deterministic way. It is not going to fail in an arbitrary way. Arbitrary way means that if it fails now, it fails towards the east. Next time it fails towards the west. Deterministic means that if it fails now for 100 times, it will fail towards the east. I know. So because I know that it is going to fail towards the east, I have written some subroutines. In case of failure, do this. So that is where the concepts of, for example, in verbs now, we now say fail open or fail close. So that when I am designing my plant or my system, I will have factored in, if it fails, what should happen? Since I know that this PLC is going to fail this way, then I will be waiting for it. That once you see that failure, do this. But if it is failing arbitrarily, I mean, this guy now, if temperature in this room goes too high, this computer can shut down, can throw the blue screen. When it throws the blue screen, if I am probably I am in the middle of transferring data from the USB to the hard drive, it can even corrupt the USB itself. So you don't know, it is arbitrary. But this is predictable. So to the person asking the question, process dynamics is, it's a concept to use in the algorithm, right? But determinism is a property of the industrial controller. So Arduino is not deterministic. Your computer is not deterministic. I can use this computer to control processes if that process is not critical. If I can live with an arbitrary failure. But because of the scale of operation in the industry, I cannot afford certain failures. All right, tell me.
Yes.
Thank you very much.
What is ladder logic? What's scale?
PID. What level are you?
200.
200. Okay. So ladder logic is the program. It's a programming language, just like Python. Right? Ladder logic is a programming language just like Python. So to program this, you use ladder logic. To program your Arduino or whatever, you use Python, right? Or you use C. Exactly. So for control systems, there are 5 languages defined that you can use to program them. They are defined by the IEC 61131 standard. IEC 61131. Ladder logic, function block diagram, sequential functional charts, instruction list. Traditionally, I always forget the 5th one. So fill in the gap. Take it as an assignment. So that's how lecturers do. So take it as an assignment. Okay. All right. Okay, PID is an algorithm. I saw it just now, Abby. Okay. So this is the PID algorithm. If you program in Python, just go and look at I've forgotten the name of the library. There's a Python library. PID. So just go and look at it. Look it up. Right. Look it up. I mean, so you can see this is a very simple program that anybody can write. The complexity here is how do you determine this value, and this value? KP, KI, KD. Don't worry, we probably do treat it in class in maybe 300 level or 400 level. Yes, ma'am. Yep. So you can see, I was explaining this graph. The green is well tuned. It is well tuned, and that is the technical term there, right? KP is high. Here it is poorly tuned, right? But this is well tuned, so you can see the transition. Let me ask you a question. Look at this. Okay. Look at this red graph. Imagine that this is the graph of the heat, as in temperature, and you are frying plantain. If your heat behaves this way, what will happen to that plantain? Because plantain has a very sensitive margin of error. You are looking at it now, and it is brown. And then your phone just rings and you do like this, boom. By the time you come back, everything is black. Everywhere will just blow up. So you understand? So you need something constant like this, right? So that you can cut it at some point. And we're working on an inter-university competition where we're going to build a proper control system, right, to control the process, right? We want to begin to promote these skills and want engineering students to have this pride in creating proper things. And it's not a type of competition where you just copy something online. I mean, because we'll take it to task. We are putting a lot of money on it. So you will have to earn that money. You must sweat. If you don't sweat, you won't win. So that will be announced later on. So you see, the green one is well tuned. Sorry. Yes, sir.
Yeah, this, I believe this is the graph. The graph is affected by the transfer function. For example, that's why the second order system when the damping ratio is less than 1. Yeah, okay, the perfect one is when the damping ratio is equal to 1. That's
what level are you?
100.
Okay, yeah, I was serious near. You know.
So this is affected by transfer function. So my transfer function of the system. So that means is it at the level of my code that I start trying to tune it, or right from the design of the, because it's the design that will lead to the transfer function?
Okay, yeah, excellent. Very good question. Very good question, and thanks for that. No, I'm a coffee. Yeah, coffee is my drug. So very good question. All right. Your transfer function is essentially the ratio of your output to your input, and that is the gain. That defines the gain. So your tuning now determines the percent of the gain you're going to apply to the process. So you now decide whether to increase the gain or reduce the gain. So maybe you say your gain times 0.001. Your gain times 0.5. And the gain you apply to the process depends on the error on the process. If the error is big, you need very high gain. If the error is low, you need low gain. Do you understand? So you go from that range. Now, how do you now calibrate whether high or low? That is where tuning comes in. So if you tune it very well, you will get this green shape. If you don't tune it very well, you will have oscillation. This oscillation is not good for processes where you are running heat. If you're frying plantain, if you are baking bread, if you're producing biscuits. Because imagine if you don't tune your process properly and you have this differential in temperature. This is the temperature that enables the biscuits to be properly baked. Once you have applied this, then you burnt the biscuit, the whole of the batch, you burnt it, and then it's a waste. So all the efforts from the raw material, the mixing, the cutting, and everything up to that point is wasted. Materials wasted, labor wasted, simply because of this incompetent engineer. Do you understand now? Yes. So that's why I said that for you guys, you have the baseline. That's why I said I'm not trying to make you an automation engineer. In fact, I don't. Well, I'm in the automation profession, but I prefer to be called a control systems engineer. So wherever you need control, that is where I function. Right? If you need control, that is where I function. I don't just automate. I go to the level of ensuring that I save you money by not giving one extra CL to 100,000. I mean, just think of that. 100,000. I mean, we did the calculation just now. 40 million. If you produce 100,000 bottles of Coke per day, and instead of filling it to 35 CL, you fill it to 36 CL. Coca-Cola will lose 40 million naira one day on that. Even if you fill it 35.5 CL, Coca-Cola will still lose 20 million naira. And if you fill it 34.5 CL, you have cheated your customer. It affects your reputation. Because the day I see it, if I can prove it, I can actually sue Coke. Yeah, they have obtained money from me by falsehood. They told me that if I pay 500 naira, I will get 35 CL of Coke. Now they are giving me 34.5 CL. So the problem is many of us cannot, it happens, but we can't prove it. Because if I was the engineer, I would rather err on the side of caution. I would tune it such that it will permanently not go above. It can go below a bit because you won't see it. You'll be in blissful ignorance. You'll be enjoying your cheating. You know. All right. Abdullah, are you ready? Yeah, we'll come to you shortly now. So the ladder program, you can see it's a programming language also. You have your contact and coils, a rung ceiling circuit, time on timer, sequence of rungs, and it's going to show that to us. Have we found a way to project it? Okay, we've not tested it. Okay. All right. All right. So all of this, you know, you can see there is a time.sleep delay. You know how to implement that in Python? Yeah. State machine logic, if condition output. You understand Boolean logic and or not. So you can really see that from where you are to being a master of this, you probably have done more than 50% of this work, even if you're in 200 level. The reason I'm saying that is that your mathematical aptitude is a thing. Don't look down on it. It's a thing on its own. That aptitude will help you to pass that jam. It's a thing. It's something very valuable. All right. Okay, we're supposed to have 10-minute break. Skillcatalyst.com Yeah, so we'll quickly do a design of the system. Mr. President, can we continue or do we need to take that 10-minute break? Huh? Yeah. Okay, all right.
Hi guys. Those are great. We'll do it on the site. Those are the site on the platform. This is why I'm really sending password to the hardware. With the bandwidth, a lot of the bandwidth, one of the trying to just so that you can connect and join the platform, right? So just telling is that so I set up so that when time to see it to go to Six. I don't believe what's worth. FCS not class. Okay, watch quality. Six. After that, everything's after that. 6G W5 D 2 7 8 4 3 6G W5 D 2 7 8 4 6. Sign off and get ready for next. No, but
This one is connected to what again?
It's just poetry. Are you taking it?
No. So that we can cast his own screen for the one.
Okay.
I think let's come on up. Just already the yes, what's the name? Yes, for this looks like something. Is your mic still? Okay. Still. Nice of presenting. Okay. Sorry, the right is yeah. It's not connected. I just disconnected. It's connected with audio.
Just the direct.
So trying to like, who does not have any, I think that's it. Work from
How about signing? All right. Yeah. We're trying to pass the conference. Yeah, I was so that I'm not scared. See that the join the court, you would be explaining something.
Ah, right. Right. Okay. Okay, great. Yeah. You should even have thought of that. Nice. So you just give me 2 minutes. People have joined I'll just walk them through the platform and Mr. President, this shouldn't be happening in EE,
exactly.
EE department.
Hopefully next year. Change. Then I'll just post something to you. It's not really, it's a new
Just where is Simon just now? Okay, let's just leave it. Do not touch. Yeah, so I need to okay. I need to okay. How do I go to okay? This okay, yeah. So so you will need to share a screen.
Yes.
Can you enable that? Okay. All right. So while he gets that done, hello. Okay. All right. Okay. So while he gets that done, I'll quickly walk you through the platform. Right. Let me see. So if you log in, because of time, so once you log in, right, I think it will bring you to this page. And then if you go to the dashboard, right, it walks you through the platform. Okay. So, I mean, some of the features on the platform. Okay, so you go to the dashboard, right? Skipping this. All right. So we have, I mean, this is the competition board. I mean, we call it the leaderboard based on how much you learn per day. And so, yeah, it records what you learned. So we have this person that has 6,000 and then 5,000, and so these are other people on the ladder. All right. Competitions will be launched, and the features will be there. Right, the performance, right? But what I want to show you today is, you go to the courses and you go to, let me first show you this simulator. I mean, there's so much to show, so I'll just prioritize what I'm going to show you. So this is simulation of oil production, right? From the wellhead through the flow line into production manifold and the separator, right? But that's not my focus today. So if you look at this, now look at this process simulator. This is a very common process in the oil and gas industry, where you have, so when you produce the crude from the reservoir, the crude comes as a combination of three fluids. You have the oil itself, you have water, and you have gas. So you bring in the crude into this, I mean, through this pipeline into this vessel, and you have to separate the three components, right? The oil, the gas, and water, so that you have a separate outlet for the gas, separate outlet for the oil, and separate outlet for water, right? And this is the control system. So you can see these controllers. At least from what we have done today, you can recognize PV, right? You can recognize SP, right? So this is the set point. We want to maintain this oil level at 50, right? And then this is the PV. So if I run this, if you go to this point and you run it, right, you can see your PV tracking the SP, right? You can see your PV tracking the SP, right? And you can see your error being calculated real time. You can see the error here being calculated real time, right? And this is the LIC, level control. So the Arduino you built, that you used level to switch on a pump, right? It's a level loop. So you built essentially level control loop, right? So LIC is level indicating controller. So you can see that there is one LIC for oil level. The next LIC is for water level, right? So you have your oil level, you have your water level, and then you have your PIC for gas pressure. You can't use level for gas. So it is pressure for gas. For oil and water, it is level, right? So you implement all those three loops on one single tank, right? And then you have your trend. So this is the trend. So per time, at time t equals to 34.9 seconds, you can see your gas pressure, your gas set points. You can see your oil level set points. You can see that it's just a difference, 50.8 and 50. And then you can see your water level and your water level set points, right? You can see all of that. You can see if there are any alarms. There is no shutdown active in this process, right? Your diagnostics, right? You can see all of those, you know. And then your engineering. This is where you do your design, right? What the separator does. So if you read all of these, I wish that the guys in petroleum engineering, they will be able to relate more. So they understand this process more. So you can see that this is a multidisciplinary system. The control systems engineer plays a part. the process engineer plays a part, and the petroleum engineer plays a part. So all of them comes together. They will give you the information about the process, right? And then you, as a control systems engineer, you define the instrumentation, the algorithm, and all the programs that makes it happen. So you have all your tag references there, right? So from your Arduino, I'm sure you understand what AI means. AI is not artificial intelligence in this instance. It's analog inputs, right? And how all of this is translated to the kilopascal for pressure and the range. And it's for control and alarm, right? And you see, so you can see analog outputs, digital inputs, and so on and so forth. You see your PLC, you see your, still under engineering, you have your tag reference, you have your PID view. So this is the PID view of the process. Not PID, P and ID. So you need to begin to make a distinction. PID is proportional integral derivative. It is math, it's algorithm. P and ID is piping and instrumentation diagram. It's a document, it's a drawing. So there are two different things, right? And then you have your IO mapping, and then you have what you call your control philosophy, right? How you want to implement your pressure control objective, your level control objective, and so on and so forth, right? So if you go back to the overview, you have that, and you can stop the process. So that's a whole process simulation, right? And you can actually inject some faults and, ask students to troubleshoot and so on and so forth. Now, for the PLC, so if we go to the PLC simulator, this is a simulator, you have a whole lot of scenarios here, right? Let's look at this tank field high-level stuff, right? This is the process view, this is the process diagram. I don't know how to, but if I start this, right? Okay, let me run. So if I run this program, yeah. Okay. Okay. Thank you. So if I run the program, you can see the tank is filling. Okay, let me stop it and let me reset. Right. So it's presently 0. Okay. Okay. If I run this program, okay, sorry. I click run. You can see the program is running, and then if I start it, so there is flow into the tank and it's filling, right? Let's see what will happen. You can see this place that says the fill valve is true, right? So you can see the color change, right? And then another color change. So those are alarm levels. When it was green, normal. When it was amber, it is telling you that you are approaching, the margin. And then once it is red, probably you have an overflow of the tank. So that's alarm. So, and this is the program that is implementing this, right? This is the program. You can edit the program here. So if you reset this and then you come here, you edit the program. You can add more instructions, right? You can change this instruction, and that's the XIC, XIO, and all of those things, right? So let me discard. Yeah, so you can do all of those things here. You can, this is what we call the watch table. Everything is on that PC. So everything that, okay, no, not everything that hardware will do. But let's say 90% of what that hardware will do, that's what we have written here. We took the physics of this hardware. just system codes that at least definitions. This would have given you all the definitions, all the fundamentals, and everything. Yes, boss.
I do some things like I don't know some.
Yeah. So yeah, I mean the platform, right, is it's growing, right? So like this now, these are the scenarios we have here. This is a PID full ladder. What's happening here? Okay. That is it. Okay, let me look at what is the scenario again? PID. Okay, this is a PID temperature controller, right? Okay, so let me just say the system is work in progress, right? All the simple controls. Yeah, this temperature. Okay, there is something just happened here. So I'll check it. This is supposed to show the full PID ladder, exactly all the input and everything, right? But there is another powerful feature that is in the works. This is we call it the sandbox. So whatever process you think of, you can build it in here. So you can tank heated vessel, two-phase separator, reservoir, right? And then you have your actuators, you have your control, your PID controller, you have your sensor. So if I take a PID controller and I drop it, let me restore this, and I drop it here, if I click on this, I can do my configuration here, right? I can do my configuration. You see that all the parameters, the KP, the KI, and the KE, I can do all of those settings here, right? So that is the strength of the platform. But like I said, it's a work in progress. Yes, sir. Okay. Oh, okay. Okay, thank you. Okay. So if I go to the simulator, so I go to edit, right? Ah. Okay. Yeah. So you can see all the, so I mean, these are the things, this might look new to you, right? But it is well below what your mind can accommodate because of your training. Do you understand? There is a difference between, let's say, an English major. If an English major sits down here and you sit down, even if you're in 100 level and you sit down, right, and they give you this task to figure out, if it takes, thank you, if it takes the English major 2 days, it probably will take you maybe 3 or 4 hours to figure out, because of your background knowledge, the knowledge you have. Now you don't even, I mean, probably you just minimize it. Oh, okay, I'm a science student, and you just minimize it, So you can look at this rung now. This rung O2, what is it doing? It is doing error calculation. That is your SP minus PV. That is what this rung is doing. The first rung is telling you whether your mode, are you living on automatic or manual, right? And then the third rung is on the P term, the proportional term, which is your KP times error. KP is your gain, your proportional gain. You now calibrate it with the error. Do you understand? And then the rung 4 talks about the delta, right, which is KI, the integral term, times error, the integral gain times error. You calibrate it by the error. And then your delta. So you have the term 5, and then the term step, the accumulation, right? So you have all of those, and to wind up, I mean, all of this, and PID, I mean, going deep into the PID is a different ballgame entirely, right? But my job today is, I want you to see that bridge between the maths you're doing in class and the application in the industry. It is not far from. If you can understand transfer functions, there is nothing in PLC that you cannot understand. And take that from me. If you can understand transfer function, I never went to any PLC school. In actual fact, when I got my first job, I mean, I did communication option at school. Because that was when Blue GSM was coming out. That's when, you know. But I got to this interview and I got an hint that this company is into automation. I just went online. And then all the automation terms I could find, I memorized everything. SCADA, PLC, PID, PID, and whatever. And you know one funny thing about interviews? If you are articulate and you show confidence in interviews, you will deceive a lot of people. So I got on the interview and they were asking me, what is your SQL? What is the meaning of SCADA? So I used to confirm that position. What is PID? I was telling them, what's communication in your CV? Because the CV I submitted was CDMA, GSM, and all of those things. I said, well, my actual interest is control systems. But because I didn't find opportunities, so that's why I made my CV. So, you know, and I got a job. You know, so bottom line, the bottom message for you today is that the bridge between what you are learning, right, to practice is, I mean, it's just a bit of effort. And once you get that thing, you are open to many opportunities. We just show that as the electrical engineer or EE graduates, you can function, even if we look at the automation industry as a subset of the general EE program, you can function in the manufacturing industry, right? You can even function in tech. You can function in tech. There is no, let me again, there is no company globally, right, that produces anything in mass that does not utilize the PID algorithm in one way or the other. Every variable frequency drive, there is PID algorithm internally. But you know what? They say that if you want to hide anything from the African man, when you put it in a book, if you want to hide anything from the tech people, put it in mathematics. Bro, what's it now? Why you open mouth? Sorry, are you a tech person? So maybe you don't stone me. Once I, you know, yeah. Because we look at this mathematics and we just get defeated. Ah, come on. Let me just take it and pass the exam and get out. But it's actually very useful. You can check this company, Control Studio. Let me see. Control Station, sorry. Control Station. It's a US company. Yeah. ControlStation.com. This company makes millions of dollars just tuning PID algorithms. You can check them out. It's a US company, very small team. Very small team. Millions of dollars annually just tuning PID. This company, they wrote software to tune PID algorithm. And they are selling it, they are making tons of money. I've taken their training before. Guess how much 5 days training is? $3,000.
Wow. Masters.
Yeah, exactly. So you can begin to see $3,000 freaking dollars, 5 days. Divide 3,000 by 5. Exactly per day. To learn 9 to 4. And then I travel to the US to take the training. So it's not just $3,000 cost. Yeah. That's the marks you are learning. That's the freaking marks you are learning. I cannot say this more than it. I mean, I cannot overemphasize this. That is the maths you are learning sitting on this wooden chair. Although when I went for the training, I sat in AC and they gave me coffee and biscuits and cake. But I paid $3,000. Well, my company paid. And so, you know, so Control Station, check them out. And you can subscribe to their, very solid company. Okay. Yeah, so that's it. And that's the platform. Let me hand over to my Oga here to, so you can share your screen. Guys online, I hope it's not bored. Huh? No. It's showing. Okay, I need to get on the meeting here. So I need help here. I just need to log into the meeting. Oh, where's the meeting?
Another browser.
Okay. Oh, sorry. Yeah, that's it.
Can just stop sharing. You can
Yeah.
stop sharing. Stop sharing. Please.
I know. Doesn't matter. Yeah, at this airport.
Right, good afternoon once again. So one code and I'm going to PLC by the PLC owned by Rockwell Automation. So there are different brands of PLCs and they perform similar functions. So just like the difference between them is the software they use and also the way they structure their software. So there's the ID is mentioned. So the Arduino ID is similar to your Arduino microcontrollers. Is also what your PLC uses. So they have their own respective software. So not to waste much of our time, we'll be focusing on the Alibadi PLC. And the Alibadi PLC has different models as well. So it has different models. So the one we have here is the Control Logics PLC. So Control Logics 5000 PLC. So now, for the PLC, there are different, majorly PLC are classified into different types, majorly generally. So we have the compact PLC and the modular PLCs. So the compact PLC is just like our Arduino, whereby the GPIOs and the controller itself, the chip controller is on the board, and everything is just within that microcontroller. So for your modular PLC, so you have the input module separately, you have the CPU separately, you have the output module separately, so which can either the analog output or digital output, as well as analog inputs or digital inputs, and you can also have a power supply. So although some classify the power supply as components, but some do not. So the reason is that I just indicate our power supply externally. So for this Control Logics PLC, the software it uses is ROS Logics 5000. So it can use ROS Logics 5000 or Studio 5000. So Studio 5000 are for plans of PLC of version 20 upward. So 21 upward, 21 upward. Why ROS Logics 5000 is for version 20 downward. So here today we'll be using RS Logics 5000. So now, aside the modules I mentioned earlier, we need to find a means to communicate between our PC, which is our laptop, and our PLC. So because our programs are going to be written inside our software, the RS Logics 5000. So after writing your program, you need to download your PLC from your PC. So just where you download from your microcontroller. So I'm using microcontroller as an example. So since you are familiar with that. So now, so the means by which we communicate or transfer programs between our PC and PLC is through our communication ports. So communication ports. And those communication ports, we have different types. We have the Ethernet ports, we have the RS232 ports, and all of that. So but for today we'll be using Ethernet. So now, there are two means of transferring programs to our PC and PLC. So I was called download. So downloading is transferring from my PC to my PLC. While uploading is transferring from my PLC to my PC. So in case whereby you go to a plant and you want to access the program written inside the PLC, so you can easily download upload from the PLC to your PC to access the programs as far as you have the right software. So now, for the Alembadri Control Logics 5000 and other Alembadri PLCs, there are two major softwares used. So the RS Logics 5000 is majorly to write the programs, while there is another software for communication. So to establish communication between your PC and PLC, and that's the RS Links. So you can see my screen, you see the RS Links Classic. So all inherited. So that's the software you use to establish communication between your PC and your PLC. Because if there's no right communication, then you will not be able to write your program or download your programs or upload your programs. So within the RS Links software, there are different drivers. So the driver is talking about the kind of ports you are using to communicate. So we have the Ethernet driver, we have the RS232 driver, we have the emulator driver as well. So in case you want to simulate, so when you don't have the physical PLCs. So now to establish communication, like getting the right driver, you go to communications and configure drivers. So here I can enable driver types. So to check the drop down. So there are a lot of drivers, but for this purpose, we're using Ethernet devices. So this Ethernet device is for Ethernet driver, where we're using Ethernet ports for communication. So I can easily add that. So this is generating. So now there's something we call IP address. IP addressing. So IP addressing is like an identification for each of the devices. So the PLC also has its own IP address, just as our PC has its own IP address. So our IP address, as you know, there are 24 octet numbers. So usually what we usually use is the most common one is 192.168.0.0.0 between 0 to 255, depending on what's not to use. So let me just use 192.168.1.1. So you must be careful. So the PLC, there is a communication mode, the one we transferred across earlier. So it's on that communication mode that we're going to set our IP address. So for this particular PLC, the IP address has been set to 192.168.1.150. So in order for me to establish communication, I must insert that exact IP address. So on that communication module. So that's what I had. Okay. So I have my Ethernet driver running. So I can close this tab. So immediately you do that. Under that particular, you can see there are different drop down buttons here. So like the particular one you are using, you are going to now see, as far as you have connected your cable, Ethernet cable, you are going to see PLC that you have connected. So they are the PLC. So this is the communication module. So in order for me to see the PLC itself and other modules, I will click on this plus sign. So this is showing the communication module. So this is the black backplane or chassis. So backplane or chassis are where we connect our modules to. So what you see here is called the backplane or chassis. So inside that backplane or chassis, there is a link between all the modules. So this power supply I'm seeing here is giving power to that backplane or chassis. So that backplane now transfer, send power to all our modules for them to show that they are all communicating together. Because your input, output, CPU, communication, they all must have a means of communication in order to show that okay, they are all communicating together. So this backplane or chassis has different types. So there are 4 slots, there are 7 slots, 13 slots, and all of that. So 4 slots is telling us that we can only insert 4 modules. So this is my CPU, my input module, output module, and my content. Those are 4. So you can't take more than 4. But for 7 slots like the one we have here, so you can take up to 7 modules. So, but here we're using just 4 modules. So these 3 modules are left alone. So in case we need to add an analog module and all of that, so I can just insert that module to use them. So the advantage of the modular is the advantage of modular PLC. So in case a module is bad, I can easily remove that module and replace it compared to the more compact PLC. So that I'll need to replace the entire device itself. So when I click on that backplane, so it has shown me the entire modules, the 4 modules are connected. So this is the communication module. So this is the main CPU. So on slot 1. So this is the input module on slot 2, and this is the output. So not to waste much of our time. So here we can see that I've established communication. I think if there is no means of communication, there is going to be a cross sign on those devices. Let me try to disconnect. I see now. So it's showing that those devices, those modules are not communicating anymore. So when I try to connect back, after a while, it's going to detect and there will be communication between my PC and my PLC. Okay, so I'm now communicating. So that is RS links for communication. So coming to my RS Logic 5000. So RS Logic 5000 is the software you use to write your programs. So let me look at that. So aside you knowing how to write programs, how to use the softwares, so you also need to know how to work with the hardware devices as well. So they all work hand in hand. So like the skillcatalyst.com is there for you to simulate programs, write programs, and see how they work. So those instructions, the PID blocks and all. So after doing that, when you want to advance to see how they really work on the plants and real life, so you need to know how to interface with these devices. So this is just the RS Logic's interface. So just like other software, so it has different tabs. So now let's create a new project file. So now this is the new controller. I need to select the exact controller I'm working with. So as I said earlier, this is ControlLogix 5000. Even this ControlLogix 5000 also has different versions. So we have the ControlLogix L5. X, L6X, L7X, L8X. What does that mean? So L5 is for ControlLogix 5000. So they simplify that ControlLogix 5000 to L5. So that's why this one is, this particular one is Logix 5561. So that Logix 5561, the Logix 55 is taking that L5. While the 61 is the exact version I'm working with. So I think it is L5551. So that's L5. X. So the X is for the 61. So if I'm working 105571, so that's L57X and so on and so forth. So in this case, I'm working with ControlLogix 5561, the first one. So that's L61 controller. So I can name my project. This is workshop. Okay. So now I need to select the chassis type. So the backplane I mentioned earlier. So we're working with 7 slot chassis. Now, this slot is to select the slot you have connected or you have inserted your CPU, your main CPU module into. So the slot is counted from 0 to 6. So it starts from, so just like our bytes. Our bytes is 0 to 7. So that's 8 bits. So in this case, it's 0 to 6. That's for 7 slots. So if my communication mode is on slot 0, while my CPU is on slot 1. So I need to select slot 1 here. So then click on OK. So I have the program open. So now, after we open your program, so there are some things you need to do in the software as well. So which is that your software only recognizes the controller. So now we selected just the controller only. So you need to also select other modules that are connected. So let's quickly do that before we establish communication. So on this tab, you can see different functions here. So, but for to insert your modules, you go to the last one, IO configuration. Guys, click on new module. So I'll quickly hide. Okay, so I have my input and output module and my communication module. So I can quickly just type for my input module and the exact type of input module I'm working with. So in this case, we're working with 32. So I'll create that. Okay, so I'll give it the name, let's say A. And I to select the slot is connected to that slot. So I'll click on OK. Then for the output module, I can just quickly search for that as well. So in this case, we're working with 32 output modules as well. So I'll create a module for that as well. So all this is just to show you that we need to select all what we have physically in our software. So if you don't do that, then there won't be proper functionality when you're working with hardware devices. So then lastly is our internet module. This particular one we're working with. So they all have their model number and revision number. So when you check the hardware device by the side or when you check the data sheet, you're going to see the model number to select the exact one that you are working with. So this is also 0. So I've done that. After me, like I said, all the modules are now showing here. So now I need to now establish communication in the software as well. So I go to communications, move active. So to see the PLC, particular controller I'm working with. So this is the driver we're using, which we have done in configured in iOS 6. So click on the drop down. So now I've selected this controller. So let me just download. I want to download the controller. For that's for my PLC. So in order to go online with my controller to see that I'm actually communicating within my software as well. All right. So now like our programs, the logic programs. So there are, if you look at this tab by your left hand side, this tab called task is where you write your programs majorly. And there's something we call, there are 3 things majorly that you use to write your programs. One was called tasks, one was called programs, and one was called routines and sub-routines. So now for the task, so the task is like where you structure the entire system you are working on. So take for example, you want to produce Coca-Cola. So that task is to produce Coca-Cola, production of Coca-Cola. So that's, and you can have up to 32 tasks. So but you must have just one main task. So that main task is the main place where you are writing all your program should be directed to. So we have what's called main tasks, periodic and event-driven tasks. So main task is the main program you are writing. So periodic is what you want to allow to occur periodically. Maybe you want after some time you want to perform this task and so on and so on. Then event-driven task. So tasks that occurs when something happens. Maybe there is a safety issue. So what we guide us to prevent it from happening. So it's where you write your event-driven tasks.
It's like we're programming. You can see like we're programming our language implement maybe timers and counters.
Yes. So under your periodic task. So it's just like a tab, like your main task. You get. So inside your periodic task, the programs are going to write inside your periodic task are going to be related to the periodic functions you want to achieve.
So how does that connect to the subroutine question you asked earlier?
Like the subroutine would be like you want to call a specific function, a specific ladder.
Exactly. So a specific unit
Yes.
to carry out something. Yeah, I just wanted to point that out. Yeah.
So
I
now,
think she raised her hand.
Okay, so from the three things you just mentioned, I want to contrast it. Are you saying that the first one you mentioned was what?
main task.
Mental.
The main task. I would say that's like set up the item. Then the other one is like then the other one is like if states.
No. Yeah.
So now, those are also the program generating. Those tasks are also the program generating. But what we mean by main task is the main task that you must include your program. That task is not going to function. But it's also the program, the ladder of the program generates. So it's just like construction. Yes, it's construction. You can structure my program to make this. So I must insert some instructions into the main task. Why the periodic key under another tab? So just to structure your program instead of it just to write everything into main task. So when someone else wants to read your program, it's going to like it's not going to understand it.
So let me chip in here. How many of you can write in C++? Okay, cool. So I mean, so now we are senior, so C++ is senior to Python. Yeah.
There's something in Python.
So in C, embedded C, you now have your functions, right? You have your functions, you define your program, right? You now have functions doing different things. So a function could just be to read from a particular sensor, right? And then deliver to, so that is how it's a similar way the programs are organized here. And I was privileged to spend 14 years in Rockwell, right? I can tell you that this fantastic software, right? I mean, a license is about $5,000. Yeah, for the license, yeah. And then you pay probably how much annually? Yeah, $500, $600 annually. So when you were saying that, can we just transfer the so you can understand the answer? You said? A what? Crack. I challenge you to go and crack it.
Like I have the RS but it doesn't have like the full functionality.
Yeah, that exactly. So I mean, the software is crazily expensive. I mean, you buy the software, it's money to set up a business on its own. But you know that all this the function blocks and everything, they're actually C++. They're implemented in C++. So when you take an XIO instruction, it is a C function you are placing on that ladder.
So that basically the backbone of the ladder logic program is
C++.
Sorry, sir.
Yeah.
I think you don't understand me. Like, do you mean because I don't really about ladder? Is it something like Scratch? You do Scratch.
Yeah, Scratch. If you want to teach a kid how to program, you give it the source Scratch, and then you have the loop block, and all the stuff inside the loop. So the ladder essentially is a graphical programming language, and it has hidden the C abstraction behind it. Do you understand? So you can begin to see when I say that your strength in this industry, you actually don't know it. As in the foundational knowledge you have no idea. I mean, if you get into this, like this, you will catch up, and I mean, based on what you already know. Sorry.
All right. So thank you, sir. So now for other each main task. So again, I mentioned 3 things earlier about main task, program, and routine. So task, program, and routine. So they're like long terms. So task is the main. The program is where you write your main programs. So even under that programs, you can have up to 100 programs in each task. So up to 100 different programs in each task. So what that means is that, as I said earlier, the task is, let's say, Coca-Cola production. So now, for Coca-Cola production, there are different sections. So we have the blowing section, because your bottles, they are just like they form. So you give bottles just small, they are blowing. So that's the section. Then you have the filling, although you might not be organized, I'm just saying that example. You have the filling, you have the label, you have the capping, and all of that. So now, those are different steps you are used to achieve that production of the drink itself. So you can now structure each of those steps in different programs. So that's how we're going to structure your programs under the task. So now for the routine is where you now write the main program, the main ladder logic itself. So the routine is where you write the main ladder logic. And for that routine as well, we have what we call main routine and sub-routine. So main routine is like the main area where you write your programs, whereby for all your sub-routines, you must, after writing up to any other program in your sub-routine, you must call those programs in your main routine. So you must come and call those programs in your main routine. So after writing them in your sub-routine. So your sub-routines are also construction. So whereby you can write different programs for different functions. Let's say you are controlling 5 pumps. So you can write the control of different pumps in different sub-routines. So after doing that, you now come and call everything in your main routine. So then just go into the main routine. And also you can write
And the sub-routine, that is what that's the
yeah, you can actually create, there are also called data blocks. So you can create data blocks for each sub-routine. So data blocks are where your data are stored. So data is related to your programs, data of your inputs, data of your outputs, data of anything. So after storing them in your data blocks, then in order for you to now, when you want to call them in your main routine, so you now refer to that data blocks to now get those data from your sub-routine, so to attach it to your main routine. So now, even if you want to write the basic program, you can use your main routine to write them and transfer to your PLC. So just not to waste much of our time, let's just quickly write the basic ladder logic program. So now, they are also called instructions, ladder logic instructions. So one was called exercise, examine if closed. How was called XI, examine if open. How was called output energized. Although these terms might be different when you work with another software, so but they work in a general way. So examine if closed, exercise. So now, out of those 3 instructions, there are 2 of them are for inputs. Why one is for outputs? The XIC and XIA are for inputs. So why the output energizes for the output. So for your input devices, so the XIC is talking about examining if closed. So your input devices can either, for your digital input in this case now, they can either have 2 states. Your digital inputs can either have 2 states. Either they are closed or they are open. So if they are closed, they are going to send the logic of 0. If they are closed, they will send the logic of 1. Good. So now,
Can I ask you a question?
okay.
So we built the water levels. Your level transmitter, is it on or off? Or, I mean, how many states can your level transmitter take? No, it can't be 2 states. Level transmitter, it can be 10%. The range, yeah. Yeah, I mean, it's from 0 to 100%. Okay, so you just did empty or open. I'm pointing it out because he mentioned that your input can have 2 states. Does it mean that I cannot use an input that can take any range between 0 and 100 on a PLC? Well, it's a question I'm asking you, so you will answer. I just wanted to use your example to point that out.
Okay. So I mentioned earlier that there are 2 major types of input devices. Okay. I don't want to emphasize that. We have what's called digital inputs and analog inputs. So digital inputs are the input devices that can have just 2 states. So digital. So like our digital signals, they can either be closed or open, on or off, 0 or 1. So now we also have analog signals. So our analog signals are the ones that have ranges of values. So we can scale it to either 0 to 100%, 0 to 50%, and all of that. So now, for your PLC, the way it works is that they work with electrical signals only. They work with electrical signals only. So let's say, for example, we have a flow meter, for example. So sensing the level of flow in a pipe. So, and that flow meter can be scaled between 0 to 100%, just for example. So for your PLC, what was called transmitters? So transmitters are devices that used to convert those physical signals to electrical signals. So in order for your PLC to understand the signal you are working with, brilliant. So the level transmitter in your own kind of project is going to convert the level that you have scaled to electrical signals. So that electrical signals can either be voltage or current. So can either be voltage or current. So and can also have its range of values, either 0 to 10 volts, 0 to 5 volts, and all. So in the case of current, can 0 to 20 milliamps, 4 to 20 milliamps. So the most common one is 4 to 20 milliamps. So that's why you're hearing 4 to 20 milliamps transmitter nodes. So when you go to the field. So in that case, your level sensor, so it's going to convert, or the level transmitter is going to convert your level physical signal to electrical signal. So which your PLC understands. So do you understand now? So analog devices, they have work with range of values. Digital devices work with those two.
Exactly. So that speaks to your GPIO in your Arduino. You configure some pins as digital inputs. You configure some as analog inputs, right? And you configure some as analog outputs. You configure some as digital outputs. In the case of a PLC, we don't need to do any of that configuration. You just buy the card. So all those things that he removed that we were looking at, so it comes like that. So you have a digital input card, analog input card, digital output card, analog output card. And that's why when it spoke about chassis, so you select your chassis, right? And then you plug in. So if you have more analog, analog inputs, you know, maybe you will buy 2 or 3 of it, put it in your chassis, and then you have your communication device, and then your processor. So your processor will read from all of those inputs and all of those things. Let's go into the program so that's time.
All right. So now I mentioned 3 major instructions, XIC, XIO, and OC. So examining closed. So what the examining closed instruction is similar to normal open instruction. So you hear normal open instruction. So examining on, examining on. So this is so let me bring it into the long. So there's something we call long. So long are like your lines of code, similar to your lines of code. So your lines of code. So on each long, you are now going to bring in the instructions you want to use on each long. So let's say for a line of program now, you know, for your normal Python and all, you can say print something, print hello world and all of that. So that's a line. So similar to the ladder logic as well. So we have long. So long for each instruction. Let's say I want to use a particular one to start a lamp, to start a motor. So the next one, I want to use it to control the timer and so on and so forth. So that's long. So each of these lines are called long. So this first symbol here is to insert our long. So when I click on it, I can easily insert a new long. So now, so this is the XIC, examine if closed instruction. So what it does is that your CPU performs 3 tasks majorly, the processor performs 3 tasks majorly. First is that it scans the status of the inputs, execute, second is that execute user-defined programs. So the user-defined, not how to write the program, so it's going to execute that program, then it's going to activate the output. So based on what you have programmed in your software. So those are the 3 major tasks your CPU, your processor wants to do. So it's working with the input module and output module, or input card and output card. So when it scans the input card, it's going to examine the instructions, your user-defined programs based on your instructions, then it's going to activate the output based on what you have asked it to do. So now, for the XIC examining is closed, what it does is that the terminal you have referred to, the input terminal, so before I go to that, on this particular input module, this is our input card itself. So these are just terminal blocks. So these terminal blocks are where we connected our inputs. Those are switches, our sensors, our transmitters, and all of that. So those are input devices. But transmitters are analog, so they are not coming here. They are going to our analog. So for our switches and our sensors, they are digital sensors, they are coming to these terminal blocks. So these terminal blocks are for connections. So whereby we are going to connect our input device to them. So there's a method to connect those input devices whereby we get our power 24 volts and connect our input device to 24 volts down to our terminal blocks. Into this much of our time. So let me just explain this. Circular input card. It has 32 pins or 32 terminals. So this 32 pins meaning that you can take up to 32 input devices. So I can connect up to 32 switches or sensors to this particular input card. So now, each of those 32 pins, so they have now respective addresses. So they have their respective addresses. So the one I want to use in my program is what I want, that's the particular address I'm going to refer to in the logic instruction. So I've connected terminal 1, for example. When I want to attach an instruction to that terminal 1, I must use the exact address of terminal 1. Because if I'm not using the exact address of terminal 1, then it's not going to sense a signal coming to terminal 1. Good. So now, what the SIC does is that examine it closed. So it's going to send the terminal I'm connected to. So if that terminal is getting a logic of 1, so then it's going to close or send logic to the other end of my instruction. Yes, send logic to the output. So examine the input status. So that's the signal coming in from my digital device, digital input device. Then if that status is a 1, it's on, then it's going to close that instruction, send logic to the other end, the output in that particular instruction.
So you see, in your C language, when you have your variables, every one of your variables is attached to a memory location. Exactly. So when signal comes, essentially what this is saying is that you look into that memory location. This examine XIC is a memory location, right? Once it sees a logic 1, then it writes 1 in that memory location, right? It will explain the rundown, and then you will see how all those inputs now becomes an AND logic to make the wrong true, and then thank you.
Okay. So now, examining open works in the other way around. So examine the status of the inputs. If it is open, it's going to so if it's open, it's going to send a 1 to the other end. But if that status is closed, it's going to send a 0. So working in the other way, and that's for examining. So output energize both, so that's it for the output. If it's receiving a 1, it's going to be 1. If it's receiving a 0, it's going to be off. So that's just output. So now let me just insert these instructions. So I have my XIC, and let me bring another XIC instruction. My output. So you can see. So this particular first one is XIC examine if closed or on. This examine if open or off. So then this is output energized. So that's the symbol that I see when I got it in, it went directly to the output side of my run. So now, after beginning these instructions, I must attach addresses to them. So to tell the particular terminal I'm working with. So now to do that, I will click on this. So now the easy aspect of this particular software is that when you click on this drop down, it's going to show you the modules, the cards you have inserted under your IO configuration. So you can easily select the particular terminal that are connected to. So on this particular one, we have which is connected to different terminals. So this address is telling us that local :2:I. So local is telling us that this particular address is a local address. Then 2 is telling us the slots where I've inserted my input card to. While I is telling us that it's an input module. So for output it's O, so that's the particular symbol. So I'm going to click on this cross drop down. So you can see there are codes and data. So I'm working with the data terminals. So this is 0 to 31, showing us that we have 32 terminals on my IO card. So now I can easily just click. Okay, let me just check. So I have my switch connected with one switch. Normally open switch connected to terminal 4. So I've selected terminal 4, then I've attached that instruction. And then I can easily select another.
So you can see the data type in front of it.
So for output is already stored. So three rather. So why O is the symbol is stored?
It's already
I select.
about 20
So
minutes.
this one I'm selecting this because I already know where these guys are connected to. So after doing that, I will need to download, right? And download means what?
Yeah, putting your code from your PC to your
Yeah, sending my program for my PC to my PLC. So the last I know this one is empty, so we're going to that. All right. So if you look at the first instruction, you can see that there are these two instructions are the same, right? So, but there's something different between two of them. I was that there's a green highlight on one of them. So that green highlight is telling us that I've connected a normally closed switch. So that normally closed switch is receiving signal automatically without activating, without pushing it. The normally closed button. So without pushing the button, it's a normally closed. National switch is normally closed. So without pushing the button, it's getting signal on 1. So that's why that instruction is unique. So I push it. So it's going to go online. So you can see. So the green, I'm holding the button down now, so it's not there anymore. So now, so this is normally open switch. So what do you see from the output? It's also showing that what that output is receiving signal. So physically, so you can see the output is receiving signal as well. Right? So that's how it works. So the CPU processes the input, then it's going to send logic to the outputs that have inserted its instruction. So that's how it works. So, and there is something we call latching. So latching is telling us that for our push buttons are non-retentive switches. Non-retentive meaning that
Don't store their state.
they don't store their states. You need to find a way to retain the logic or the comments that you are passing through them. So you can easily do that in your program. So, and let me go offline. So I can insert a large. So this might be looking neat to you guys.
very new.
No, I mean, and it's very logical. I mean, I will explain it to you now, and you will see that it's something you can relate to. Let him just do what he's doing. So when you begin to, let's continue writing. When you begin to look at it, for you to have an output, right? For you to have an output, this and this must be true. That and this. For you to have this wrong, for you to have this output, this input and this input must be true, meaning that this must be 1, this must be 1, for you to have a 1 there. If this is 1 and this is 0, you have 0. Now, this branch is made creative. This or this and this will give you an output. What is difficult in this? we have intimidated you with the symbol. So the principle behind it, I mean, we didn't talk about OR and logic. It's something, I mean, I would take for granted in an EE class.
Yeah.
And what is the principle of running your ladder logic? If you develop all your code, right? All of it is speaking to memory. Who doesn't understand memory locations here? These are Excel sheets. I mean, where you store your addresses, right? When the sensor signal comes, keep it here. Now, check. So this will go to that memory location and check. What is the status? Is this one? Yes. Is this one? Yes. Then, if this and this are true, then that's not logic. Can you write this in Python? If this or this is true, or, if this or this and this, get an output. So meaning that if this is false and this is true and this, you still have an output. So it's and, or, NAND, NOR, SOR, EOR, XOR, NOT. That's what we are doing. All the instructions on ladder logic. I don't think we have how many unique instructions. Maybe, I don't think they are up to 10. Yeah, I'm telling you, I don't think they are up to 10 unique instructions.
So does it include like, yeah, because we actually did the official programming on 500 level.
Yes, addition, yeah, addition instruction. Jump, move, all of those things. Timer, count up timer, countdown timer. What's difficult in that? Time on delay, time off delay. But if I want to intimidate you, I will just give you this bam. Oh, yeah. And then you will shut down.
Yes, sir.
In your mind that this one. No, it has. I mean, have you not downloaded or uploaded? That one still confuses me. So have you not downloaded or uploaded firmware to your Arduino? That's exactly what we're doing. So that's why I said that on that platform, if you learn all these basics and you go meet him in a classroom, you will have 1001 questions to ask him, and you'll be better off. You'll get more value from that training. Do you understand? Even the function blocks. The function block, as the name implies, is a function, it's a block of function. It has inputs. You wire in the inputs, and then let me finish your. Yeah.
All right. So basically, so that's how it works as I explained to it. And so for the second one, you can see. So these two combined, one of these was send a signal, then combine with this. So that's what will allow our output to be energized. So let me just open this so you can see. So this is the point now. So just this try to break this particular one. So it's going to be split logic because this is an addition.
Okay, you can see it. Yeah.
So this particular one now. So I've activated the switch. So and by doing that, is examining if the switch is on. That's XIO, right? So when the switch is on, meaning that when the switch is low, it's sending the 0. So it's not allowing logic to pass through this and logic. So but these two instructions, so one of them can send logic as far as they are all, they are in parallel. So one of them, as far as one of them is true, then there will be a transfer of logic. So then they activate this. So the way these guys are responding. So those are the switches that work.
So these are the inputs. So they are active. You know, this is a demo box. So those things installing, they are like the inputs. What will come in from your sensor? Well, I want you to explain. I mean, if we don't get anything, I want you to explain why this is on, despite this is not on, and the concept behind it. Okay. So that we can round up.
All right, fine. So for this first one, so this particular instruction is attached to this green switch. this switch is connected to the terminal. So this extension is attached to this main switch. Then the second one is attached to this red switch. Right? So this output is attached to this lamp. This lamp is an output device. It's a digital output device. So now, the green switch is a push button.
Yes.
And you said earlier they are not intensive, right?
Yes.
They don't retain logic. So when I push it, there will be a transfer of signal
Yeah.
or voltage.
You can see,
Yeah.
it's on now.
I see.
Yeah.
So when I release, what happens? It's off.
So why did it take time to turn off the?
So that's the response.
The response side.
So now, when for the second one now, I said it's attached to this red switch, right? So this green switch is normally open push button. So meaning that without pushing it, it's open. So when I push it, it's going to close. So when it closes, it's going to send signal 24 volts. So now this second one is the red push button. It stays in the normally closed state. Without doing anything, it's the normally closed state. So meaning that it's sending 24 volts automatically without pushing it. So when I push it, it's going to stop sending that 24 volts. The screen now starts.
So you can see it's off.
It's off, right? So now, this output. So what you observe when, let me stop this. So when I push this, what you observe on the lamp, it's on, right? Good. So when I push this, it's going to go off. So
So let me explain it. So latching. I mean, that's why we are engineers. We have a push button which is on off, right? Normally open push button. You want to switch your generator. You press it once. Your generator starts. Normally, if you release your hand, what will happen? Your generator will go off because it's a push button, right? So you have your push button normally open, you have another push button normally closed, right? So this is your normally open. You press it, you make this connection. Normally close is already making the connection. So you have this and this. Both of them are true. They give you an output. But you cannot keep your hand permanently here. Because once you release your hand, this will become 0 and 1. Then you have 0. So when I said that, how can we remember the start state? We cannot go into the rationale behind it. It's a safety feature. So once you press this momentarily and this line becomes true, we now take the state of this photo, this same state, which is 1. We copy it here. So when you press this momentarily, this becomes true, then this becomes true. Once you release your hand, this goes to 0, 1, but this becomes 1, 1. So your communication part now goes through this place. So your motor still stays on.
Are you saying that if I press the button for like 3 seconds, I just need to leave for the next one?
It will stay on.
To stay on.
The seconds doesn't matter. It's a push button. You just press it, let's say momentarily. Right. So if for me to switch off this, let's say motor, I only need to press this.
Okay.
This is normally closed. So once I press this, then this state goes to 0. Then this will now become 1, 0. Then this goes off. Do you understand? So you see, it's just simple logic. The way you read ladder logic is that you read from left to right, top to bottom. Do you understand? Left as in row 0 to right, then top to bottom. So you can actually use the state of this guy multiple times, depending on the logic you're writing. So that is how we implemented the latching. So we still use our normal push button, normally open, normally close push button. I mean, you understand the concept of relays, right? Relay has three things. This one is in between. So one is normally closed, the other is normally open. That's the concept. Thank you, sir.
Wow.
So that's how ladder logic works, basically. So after doing that, you download your PLC again. You can go online. So now this data online, so that's why you're seeing this green highlights. So you can go offline. So in the case where you get the PLC that already has a working program, so you can upload from your PLC and go online. So in order to read, maybe you want to see where it touches the program. So you can go online to see how the logics are flowing. So that's basically how it's always started. I think we can.
So I mean, we are rounding up now, right? And see, many of us who benefited from people ahead of us, and that's why I could call on tag automation. I mean, the MD, what's Israel's designation? Oh, he calls himself the leader. Don't mind the humble guy. He's the owner of the company, right? He calls himself the lead, but he's a young man, right? And he's doing fantastically well, right? These are people you guys need to network with. You are still students. If you step out of school, they will be looking at you with different eyes. Now you are students. Take advantage. I mean, reach out to them, right? Your internship and whatever. Ridwan, you participated in the DEEP program, right? Was that your first exposure to automation? You participated as a student, right? Yeah, that was 2020, 21, yeah, I think that was when I was the ISA president, right? And he participated in that DEEP program, and he wrote a LinkedIn. I was actually impressed that that catalyzed his journey. Like I said, the long and short of all of this, I didn't come to make you an automation engineer. I came so that you guys will realize the advantage you have in your engineering program. Don't just dump it for Python. Yeah, no, that's the message. I mean, that's it. If you go a bit of a step further, right? Python is a piece of cake.
Yes, sir.
Honestly, if you can write C, what is Python that you can do? I mean, in this room, the knowledge, the mathematical knowledge in this room alone is significant. If we put all of you in a team, you will solve serious problem in linear algebra, in matrices, in differential equations, and all of those things. You can develop algorithm, right, for security drones. It's right there in you, right? It's now for you to determine what your potential is. Even if you're going into banking, I mean, let's say for survival, it should be with a mindset that, okay, I'm not just going to be a teller. You can develop algorithms for security in banking operations, for loan disbursement. You need to prove that, I mean, this 5 years suffering, this 5 years suffering is not, I mean, you understand what I'm saying? So, thank you very much for your time. It's been, it's been a wonderful learning opportunity, even for me, interacting with you. And I've interacted with guys that have seated in this room in the past. And today I am very proud of them. In fact, me, I like food. One of them called me one day and took me to a hotel and bought dinner worth 40,000 naira. Because I'm not the one paying for it. I just, he paid for it, and me, I ate like, I was just, because it was a buffet, so I was just packing the meat and until I couldn't move. 40K, I would have begged him to give me that 40K, but I don't want to derail myself. So, I'm not big, I'm not fat yet. My own big man will not go to a hotel and buy 40K food though. I'll go and buy at Amala Yameta, Amala Sky, 3K. I will chop Amala and Abula. But this guy took me to a hotel and said, Oga, eat anything. I said, you be the Oga now. and one of them, I was in Houston once, and I just told her I was in the US. She flew 2 hours just to come see me, just to come say hello. And I was so impressed. You know, she flew 2 hours. She lodged in the hotel, saw me. We spent probably a total of 3 or 4 hours together. And then she flew back to our location the second day. And that's what it should be. Within 2-3 years from now, where will you guys be? Do you understand? Where? So that is a question I want you to ask yourself today. I want you to go and sit down, recalibrate, right? If you're going to Japa, a second passport is important because we're Nigerians. I won't lie to you, right? Love your country, but if you are not standing on your feet yet, you cannot help anybody. That guy that bought 40K food for me, it's an experience I won't forget because it was someone that I was buying 1K, 2K data for. Just maybe about 5 years before that time. So you can see the change. And that's why I sat down and enjoyed that food to my ad content. All right. So the bottom line is that you guys have it in you. Don't cut short your, for those of you that are entrepreneurially minded, begin to think of cutting edge solutions. There are so many funds that you can take advantage of, So bottom line, the future is bright. Take hold of it. In my final, how can I get back to that slide? Oh, okay, I'm not sharing. Yeah. Sorry, can you help me? Okay, my screen is still okay. Okay. Yeah, okay. This is not what I want to share. I want to go back to this slide here.
Benjamin.
Yeah. Okay. Is it okay, it's not being shared. Okay. No, it's not being shared.
Is it not sharing?
It's not being shared. It's not
Well, then let's share.
I can share now. Where is it? Yeah. Okay. That's it. Oh, okay, that's what it shows.
Okay. It's another one. Probably open it on.
Okay. Well.
Call him outside.
Okay. Well, I mean, so my final admonition to you guys will be from this slide. Okay. I think help me to just share.
So what do you want to do?
I want to share this. We stop sharing. That's the share button. Yeah, this one. Yeah. Okay. So, thank you very much. So the final admonition is just like the control algorithm, the mathematics, right? You have efforts, the smart work, which is your proportional term, your integral term, which is the character and integrity, and your derivative term, which is the foresight, right? You have all of those, and you can see the analogy. You are putting in effort in your studies, right, and other things you are doing. And then you are adding character and integrity to it, and then foresight. All of this will help you to anticipate where things are heading, and then it dampens overshoots and it stops burnout. So you can see that when we say mathematics is the language of life, we are applying it to us personally, and then we're using it also to run the plants. And that is what you should pay attention to. So, let me see. Yeah, we didn't have time to run through this design, but I think what you have done today has been fantastic so far. So the last question, did AI produce these slides?
Yes.
Yes. Claude, specifically, how? Huh?
Yeah, I'm familiar with Claude, so that's like
The Claude did the graphics, you mean?
yes, the graphics, but the content.
Yeah. Do you agree?
I don't know if it's Claude, but it feels like it's AI. But I don't think
The AI created that analogy.
no.
Who created the analogy?
Human.
Okay. So the point here is this, right? AI will take our jobs. Is it absolutely true?
No, I disagree.
No. AI is not going to take your job. AI is changing the way we work. I woke up 2 a.m. to build these slides. I was supposed to send this to you yesterday, right? When did I send it? This morning. I woke up 2 a.m. to build these slides. What I needed to put on the slides is right inside me. Without AI, this would have flopped. So AI was the tool that made my job to be effective. So the reason I put this is whenever you get assignments, in as much as you use AI, make sure the thinking to prompt that AI is from you. Don't just copy AI. AI is just statistics, probability.
Sir,
Do you understand?
sir.
And that is where the difference is also going to be in the marketplace. Your knowledge and use of AI is what is going to stand you out. Someone sent me a CV, and the moment I saw this, I said this from ChatGPT. At least go and humanize this thing a bit. Pretend that why would you just boom with all those stuff, and then you sent it to me? That doesn't make sense. It doesn't speak well of you. Humanize it. So AI helped to produce this. AI was the assistant. The content came from me. So I wanted to pass that across. And where this stack can take you, right? These are the possibilities for you, right? You need to have a document where you can identify where you are and where you need to be, depending on where you want to go. You want to be an IoT embedded engineer, be a proper embedded engineer. Don't be the embedded engineer that just takes Arduino, whatever online, and then copy it. If you are doing a serial communication with anything, understand the serial protocol. If you are doing Modbus, understand the Modbus protocol. Don't just be that copy type engineer. All right, so this, Scale Catalyst, a track for every pivot path, right? You can explore the platform. And, so AI contributed, right? The human brought in 20 years of industrial automation experience, knowledge of this specific audience. I knew I was going to talk to UI students. So AI didn't know that, right? Deciding the coursework, right, was the anchor, connecting PID gains to character and integrity, right? And then knowing when AI answer was wrong. So you still need to govern your servant. AI is a servant, and that's how you should treat it. You're still the master, right? So there are some other tasks that you can, look at. The simulation is waiting, his school is calm. Now, based on all the mathematics you are learning, would you say that they are useless? They are not useless. I'll share one last experience, right? Yeah, just 2 minutes. I was a young engineer on an offshore platform in Chevron. I was working for a US company called vMonitor. $500,000 invoice was hanging on us commissioning the products. Now, they wrote that firmware in the US and they use the pounds, their metric to write the firmware. The firmware was correct, but the standard against what we are measuring, we use metric in Nigeria. It's different. The formula upon which the algorithm, upon which this firmware was based is called AGA3 algorithm. You can search it. That algorithm has 3 inputs, physical inputs, and up to 60 constants, right? And then we tested it, we got almost 10,000% deviation. It was, and $500,000 was hanging. I cannot submit my invoice because of if I don't commission this. They wanted a 1% deviation, whatever. I wasn't there when they wrote the algorithm, the whatever. So, and it was weekend. These people, weekend, they shut down. So you can't call anybody. I was the one sitting offshore in a field called Meren, Chevron field. And so it was my responsibility to resolve. And then I had to sit down. I took Excel and I took all the parameters, put it in Excel. I compared what that is getting and what this is getting to what the ideal should be. And then I started playing with the numbers. Guess what? I was able to resolve that error to 0.01%. I mean, it's not because if I didn't go there with an engineering training, if I didn't go there, if I don't have that mathematical aptitude, one of the factors causing the error was there's something called beta ratio, the ratio of the internal diameter of that pipe to the external diameter. You now need to iterate it. The standard software we're measuring against did the iteration 20 times. That is, you get the answer, you do that iteration 20 times. I had to figure that out from Excel because I modeled everything. If I had a morbid fear for mathematics or physics, I would just looking at 60 parameters that are constant. Some of them you have to derive it. It's intimidating enough. So school is definitely not scam. When they are saying it, don't say it. When you get Python also and it makes you money, do it. But it can't be your permanent gig. There are some things that you will do, right? That even when your strength wins, I don't even want to go to the field anymore. I want to sit in my house in front of the PC and make the money. Do you understand? There are engineers. When I was with Rockwell Automation, my day rate was $2,500. I mean, it doesn't come to my pocket, but my company will send me to a Chevron field, and then Chevron will pay for a 10 hours work, $2,500. Huh? I mean, that's a normal day rate in the oil industry. So a Rockwell Automation, a Siemens or whatever. So, and you say? Yeah, there's money. That's what I'm trying to tell you. But the money is not in Python because low-hanging fruits. If you look at the founding tree, right, you will realize that the nicest and the juiciest mangoes, they are always hit somewhere. You have to climb to get them. But the one here, they are either not right, they are black, or start eating or whatever. So Python is a low-hanging fruit. But maintain that edge that you see have access, even when the low-hanging fruit disappears. You see have access to that juicy. You know, I told you I love the sound of my voice, but I have to stop myself, otherwise Joe will throw me out there in station. Thank you very much.
Presence of time, your expertise, you bring us a lot. I'm telling you, guys, let me tell you something. You might not really know how much. What you mentioned that you went for a $3,000 training, right? Just for 3 days. I can tell you that when you go to here and go or that will sort you towards something like that. All you go to here is pretty much what that $3,000 training should give upon. And you don't see it like, I don't think I really understood this here. I don't think I really grasped it. See that the foundation, see that the first thing that you will get to do and then build something like this, right? And so you've gotten a lot of value. I don't know how to communicate this, but you are like 500 level, and maybe it just resonated better and it's value. You that you are in 100, 200, 300 level, understand that is an eye opener, is something to build your interest, to build your enthusiasm, and to open your eyes to the world of automation. Automation is very large, and PLC is very cornerstone for automation. And to be honest, it's a very, very, very pristine privilege to have an engineer that could take this whole lecture, facilitate the whole training and workshop. And so once again, can we just give this is what this I will see the PLC, but it's the first time I will see the PLC actual action, like actual action. If the other time I see PLC, like explaining the whole package here, just that top part, not so just that top part, I just think they are packing them to and give or something. I also saw one at our station like but it was not functional. Zero functionality. But here it is really it is an opportunity, right, to see the PLC work, to see it in action, like you could download the what biology to the kit and try to work. And the thing is, as well like this, you might not understand. Like you might not understand. Well, I know one of our the graduate now, engineer Alfred. He won 1 million naira at Nigeria Station last year. He graduated of electrical here in UIT. When he started to us, he was like, Joe, we should vote for president of Nigeria because bringing this thing here, he knew the value. He's already in the industry. Some of you might know Salome too. Yeah, she's also in the industry. She wanted to go over. Like, they didn't have this opportunity, right? And so you have the opportunity, might not know where, might not understand. But the exposure you're doing, the experience, the mindset.
Alfred is actually online.
So, exactly.
Yeah, thanks.
So it's online. So it's really an honor to have a gender, to have an session concerned. To be honest, I'm without words. And also, Mr. Abdullah, the privilege to have him take us through the practical, take us through the fields. We also want to appreciate our ISC people.
Mr. Ridwan.
Ridwan, yes, Mr. Ridwan. And it's looking forward to maybe having a student society for the IFC. IFC is International Society of Automation. It's looking forward to having it here in UI. So we hope that will come to fruition before I graduate. So we'll have one and maybe have someone precise about that. The first ISC student of Nigeria in UI, right? It's very good to have something like that. And so when he communicate with you and we'll also get that something hopefully. We also want to sincerely appreciate our technologists, Mr. William. And he also enjoyed the program. I could see that he was just following, and he also enjoyed the program, and enjoyed the training and workshop. And so we also want to thank you guys that showed up. Once thank all the people that came with engineer Dako. Once thank the Miss Akbar. Once thank all the people that came with him. And he's really
them controls.
Yes, them controls. Yes. We also want to appreciate their parts in this, right? All of them things together to give us a handful pack of PLC, right? A handful pack of PLC knowledge, PLC insight, and the sincerely appreciate. Before we go into further modality, before we wrap up the program, I'll just ask all of the questions. So I'll share this our small gifts, if you mind, right? So the first question, I'll just I said something. He said there's a difference between skills and non-verbal computer. Anyone that can just what's the difference? Yes. Yes.
The PLC is
yeah, thank you. Yeah. Thank you very much. Okay. What is the language of the PLC? What's the language of the PLC? Yes. Ladder logic. Thank you very much. Okay, our ISA people want to
know you ladder logic.
Yes. Can anyone mention any other?
I mentioned four, I forgot one.
Okay. So yes, you mentioned about 4 or 5 people. We are more familiar, especially in the PLC course that we are taking. So it's one of the, I think it's probably the most popular, right? Yeah. For Siemens, I think they use PIA Portal as their simulation software. For Allen Bradley, they use logic. And so I think TIA Portal is like accessible without $5,000. It's also licensed already because I think, or maybe not for clients. Because I think some people trying to send on to it.
No, you can. I think TI Portal allows you to have a trial version.
So yeah, next question. All right. Mention 3 aspects of mathematics that comes to play when you are talking about automation. 3 aspects of mathematics. Yes. Okay.
Functional expression and differentiation.
Integration and differentiation. Okay, any other person? We have about yes. Algebra, yes. You have Atlas, you have Zen Transports, you have all those transfer functions. You have Atlas, so who else have to say that? Okay. So last question. What's the name of the platform idea that will introduce us to?
I want to scatter it.
Yes. Thank you very much. All right. Let's move on. While we were doing the question and answer section, our very own staff advisor, please stand.
I want to talk video, right? Don't do video because see, I missed most of it, and it's a shame. You guys are more fortunate than I am because I missed, and I hope you gained. Because that's going to be very, very painful to bring such a mighty man to University of Ibadan. For you to go and then you don't gain from it. So I must say that on behalf of the students and of course the department of electrical engineering, we are so appreciative, engineer for granting us this rare privilege. Okay, yeah, this is always enough.
Thank you very much.
Thank you very much.
Thank you so much.
So I would like to mention that Dr. Rifani was one that did the so our water lecture series of course that tag me up with engineering to manipulate your study. Even for the PLC change, it was deep and Dr. Rifani was it's a bad good of right? I would sincerely appreciate him and appreciate all the other because it's a privilege to have him as our staff advisor. We sincerely appreciate. And yeah, I think bringing the small jobs that we have for our students. And thank you very much, everyone, for coming around. Sincerely appreciate the time. People want to go and jack, want to go and read. They spend the time to phone. Yeah, so I know you because it's something, right?
Yeah.
So also any other work came through for us for our handling. We have about 30 to 50 people in the handling. Some people are on about, well, at least we have 30 solid people in the handling. And for ESC 32 allowed us to access the skill catalyst platform to submit and to engage the platform for the ESS course. We sincerely appreciate. You also promised to give us a number of ESP 32 boards. With the red board. I know what I mean, right? And so we sincerely appreciate, thank them, thank the team, thank everybody that put this together. When I am this slide will be available, you want to access the site, want to connect to inside that point and connect to
all you guys talking. I don't want to share it with you. And so, I went to and start complaining to very fast. Because I have the privilege of, let me say, the association pass down because we have some relationship outside the association, in terms of speaker academies, some online meeting connected. I got my posture, like I didn't want to. It's just the fact that I went for a training which was conducted by IHC and participation in the training because of my mission. Very good. And I'll explain more than thing. And somebody so it's just like some unique guys don't you put an effort just make sure you put an effort. People watching and people taking your video. Like they think a lot of things I know so many people manifest I know some leaders, some CEOs just say reduce my I know by the time I don't get to apply for a job or we come close and I just there's when you check some talk oh you see and give you more edge. To give you more edge compared because they compare they say the conversation is better than you just for the person. I know if I don't know if I think I was to share, which you will do. I'm looking for the job there. To give you a little edge. So please and please know that there's evidence. Please put all your emphasis. It's I would like to quite this life lots of opportunity. Even in school. So let me say I'll be partial to make money. Even though you want to study, you want to know the in and out of it. But there's this back end, but it's not even about it now. That's why it's make an impact as well. So so by God grace, we'll see how we can get you guys no more about education, about that people in charge and see how we can do it. If that is allowed, we see how we can make it functional. I'm not going to do this. But we have plans to bring some help into the come and do communication about highest scholarship, trainings. With that, I'm going to do how let's see I've done 2 trainings, which I know it costs more than 2 million naira. From ISM, we spend more than up to 8.5 million. But I know if I'll do that training, I'll start with information. Or if you get information, I'll spend like 2 million naira. But we have and some other situations, I think you're able to subscribe to us. Even because the thing is that this ISS space right now is quite small compared to some other industries and some other sectors. When you see operation at the moment, it's not that much. Even this thing I was talking about, I went to one of the engineers come to me, which I same thing as this, same thing as sick automation. So that's how leadership is still for now. So just try and make sure you quickly grab what you can grab before it gets too big guys. If you don't have the money or if you don't have the you'll be able to do it. Thank you very much.
Thank you very much, everyone. Sincerely appreciate Isaac coming around, and we hope that as soon as possible we'll have the assistant station here and we'll give the donation and make it big and invest it. Right? So thank you very much. Any final speech from anything? All right. So yeah, next work you can meet our facilitator, you can connect, and yeah, have a nice time. Thank you very much.
But think about it very well. You always see CAP in front of my name. Okay, go on. Thank you. I got so much right.
And I remember that same around you and the engineer Amonti,
Oh, really? Okay. Yeah, I mean, they supported this too. Wow. Yeah. He was supposed to send an engineer when he's not around. Yeah. It's a very good support.
Thank you.
Yeah, praise the Lord. All right, praise the Lord. Yes. Yeah, buddy. You are talking alone. No, so we learn together. You are chopping alone.
By waiting for
Okay, I heard what it seems so.
Thank you. I just wanted to ask you some 100 people now. Yeah. I don't know if you can help us. And my other classmates are here with internship opportunities. Because we still go for our IT.
Yeah, so that's why you need to network.
All right.
Right. That's why you need to. Yeah, I mean, when it's time, if there is space, tag automation. That's why I'm mentioning them.
All right.
Right. I'm going to write a LinkedIn post and publicly thank them, so you can jump on it. And but you can collect Abdullah's number. You know. All right.
Thank you very much.
All right. Read one also in this organization. They might be able to provide it. You too, tropical guy. All of them. Monday. Okay. I'm Tuesday.
Like power
Sorry, I didn't get the question.
like make the final year does that mean like no, I don't think
Whether it's implementation with these power engineers, right? Still, what's most important is the so-called specialization is not a specialization. The beginning of specialization at the level of masters and whatever. But this mathematical knowledge, the engineering training you have, whether you are in power, you can see what you see. Right? Even power is hot now. Nigeria is aggressive about power development. So cement is doing a lot of work in power. And then renewables. Renewables is another thing. The hot area. So I mean, whatever you
I'm trying to buy the password
in engineering, particularly renewables, you are covered.
What do you think about biomedical engineering?
Fantastic. It's a niche. I once held a job as a biomedical engineer. And I was preparing. I didn't go to the training. They gave me the manual, I studied it, and I was able to repair dialysis machines. I was fixing dialysis machines for UCH.